Hello grade 12s, welcome to my channel, and it's about that time where we revise for the finals. So my advice is pay as much attention as you can to these latest pieces of work I am going to post here. So I'll be looking at some full papers, not all of them of course, but I'll choose what I think is going to be good enough to prepare somebody for the finals. Otherwise, please don't watch this video if you're still carrying on with your trials and you wrote this paper. But if you did not, it may be just a good one to look at so that you can prepare for your next exams. Alright, so instructions. I cannot overly emphasize the importance of instructions like that and instructions like this. And it's just a matter of you being aware that diagrams are not drawn to scale, so don't try to read too much, but they will somehow transmit the necessary information. And of course, you've got an information sheet to assist you in sorting out some issues. Okay, so we know that we're solving for x in 1.1. So 1.1.1. So we've got here x squared equals 5x. Now to solve this matter, this implies that x squared, we transpose that, becomes minus 5x is equal to 0. Now when you're dealing with quadratics, you always want to isolate 0 to one side. And then here we can see to solve further, we need the highest common factor, which is x. So this is going to factorize in this manner. All right. And then once we've got that product, we know that x is going to be 0 or x is going to be a 5. Now with all of these solutions, guys, you need to make sure you check if they balance our original equation. Our original equation is this one. So these solutions need to balance that original equation. So when you take 0 and place it where x is, everything becomes 0 on either side of the equal sign. So this means this is a good solution, at least. Then we take 5 and substitute there. 5 squared is 25. Put a 5 there, it's going to be 5 times 5, which is 25. So the left-hand side is equal to the right-hand side. And then, of course, you're getting a mark for this factorization there. So that's how we get those 3 marks. Nice and easy. So 1.1.2. We are given x squared minus 2x minus 13 is equal to 0. And the clue here is that we're solving correct to 2 decimal places. So this already says a general quadratic formula is important here. We know that according to that formula, x is minus b plus or minus the square root of b squared minus 4ac, all of that divided by 2a. Now where are these? We know that the coefficient of x squared, which is a 1, is our a value. And secondly, we know that the coefficient of x is our b value. And the constant term is our c value. Okay. So always take the signs along. So we substitute. Minus into, this is now minus 2, plus or minus the square root of minus 2 squared minus 4 into 1 into minus 13. We're dividing that by 2 into 1. At this point, I don't waste time here. You can clean it up a bit, it's up to you, but it's time consuming. If you can handle it, just do it. If you can't handle it, then don't do it, okay? It's as simple as that. Okay, so my first solution is 4,74. Okay, or x is going to be, now we just try to go back to change the sign. And then our next solution is minus 2,74. Remember, we're told we are rounding off to 2 decimal places. So this is what we do. Now again, in the original equation. So again, you take these solutions and substitute in the original equation. Since we rounded off to 2 decimal places, we can actually here, because we can see it's a whole number there, so we will round off to the nearest integer. So when you substitute this in there, rounded off to the nearest integer, we should get 0 is equal to 0. In which case, we could accept that as the correct answer, and then you check this one if it balances out. And then of course, a correct substitution into a correct formula is the extra marks. So this is how we score those marks in that question. Nice and easy. 1.1.3. We've got here x minus 2 into 1 minus x. This is less than or equal to 0. Now this is already in a factorized format, which makes it easy because you can find your critical values there. So what I do, I take our binomial factors and put them on our table. Again, guys, I would advise you, this is a technique you need to learn and master because it can save you some way along your solutions for other sections, okay? May not necessarily be for this particular section, but in functions, you may need something like this. You never know. Okay, so our critical values here, we're going to get 1 and 2. Okay, so this is when you're solving the brackets. And then we ask ourselves, say, look, when is our first binomial factor going to give us a 0? This is when x is equal to 2, right? Because a 2 minus 2 gives us a 0. What happens when we put a value of x in that same binomial factor that is greater than 2? Say a 3. 3 minus 2 will give us a positive answer. This will keep happening until positive infinity. If we establish a 0 and one sign as positive, this side is going to be negative because this is effectively a number line. Okay. As you can see, when you put a number between 1 and minus 2, which is this region right here, that could be a 1,5. 1,5 minus 2, it's minus 0,5. When we put a 1 in there, we get a minus 1. When we put a value less than 1, which you can take a 0 out of convenience, you still remain with a negative number. So we're interested in the signs. Then we come to the next binomial factor. We ask ourselves again, when will it be 0? When x is 1, right? Because a 1 minus 1 is a 0. Now, we want to check this region. What happens when we put a value between 1 and minus 2? We can put a minus 1,5 over there. In fact, a 1,5. 1 minus 1,5 will give us a minus 0,5. And when we put a 2 there, we still get a minus 1. And when we put a value greater than 2 for x, we still get a negative number. So if that is the case, one side is negative, there's a 0, this is a number line, so that one should be positive. This is when you understand how these things work. Then we know here that we are doing a product, okay, because those brackets, it's purely multiplication. Now we say minus times a plus is a minus. Minus times 0 is 0. Minus times a minus is a plus. 0 times any number is 0. Positive multiplied by negative is negative. Now, where are our solutions? Because this is the part that reads our solutions. We can see 0 is included. So we will place circles at the zeros. But those circles are filled in to suggest that those solutions are included. And we see now that the negative side is in that direction and also in that direction. So we make a conclusion now that therefore here it means x must be less than or equal to 1, or x must be greater than or equal to 2. That's the solution to the puzzle. Okay, so I'd like to show you another technique quickly, but I'm just going to wrap it up pretty fast. So the other tool that you can use is the graph, because this is a parabola. How you do it, you just multiply that x to that minus x to get our minus x squared. And from there you can see the sign, the coefficient of x squared is negative, meaning our a is less than 0. You know when you're dealing with functions what a represents. And this suggests that our parabola is a grumpy face parabola. Okay, it's concave down. And when you put it on here, you know that the critical values from this equation are essentially the x-intercepts. And then you draw a parabola, and from this parabola you can see the section that is equal to 0 is in here. So we are at 0 at the x-intercepts. Okay, now if we're going in this direction, as you can see to the right and to the left of those x-intercepts, we can see that the graph is below the x-axis, meaning it's on the negative y-axis, and that is the less than 0 part. And from here you can draw the same conclusion as we have drawn. So these two techniques I would advise you to learn and master, because they will save you when it comes to functions. Questions that are a little bit technical, they require this kind of solution or solving. All right, so let's move on without wasting any more time. Okay, where are the marks? Obviously those two solutions are important, and the chosen tool, be it a table, be it a graph, or just a simple number line. That's how you get those 3 marks. Now let's get to this next question. So 1.1.4. We are given 2 times the square root of 2x minus 1 is equal to x minus 11. Now all we do here, we know that once the surd is isolated, we never have to worry about a lot of things. We just reproduce this one more time, and then on this step we just do inverse operations. To remove a square root sign, we square both sides. What you do on the one side, you must also do on the other side. Now 2 squared is 4 into this one will just be 2x minus 1 is equal to, we fold this, it's going to be x squared minus 22x plus 121, which is 11 squared. Certain things when you're a math student need to come naturally, okay? Don't be wasting time. So this is going to be 8x minus 4 is equal to x squared minus 22x plus 121. And then we now arrange things. So this is going to be x squared minus, when you transpose the 8 to that side, it becomes a minus 8. So this becomes a minus 30x. We transpose the 4, it becomes a positive 4. So it's going to be 125 equal to 0. Now, we can factorize this business right here using our grade 10 technique, which is very important. to learn. So the brackets are both negative. 125 is basically 25 times 5. And minus 5 minus 25 gives us minus 30. So we can see that x is going to be either a 5 or x is going to be 25. Now we've got a set, so we need to satisfy certain things. There has to be a real number there, or a rational number if you want, under the square root sign. Secondly, we need the left hand side to equal the right hand side, because that's an equation. So when you put a 5 in there, it's a 10. 10 minus 1 is a 9. A positive square root of 9 is a 3. 3 times 2 is a 6. Then we put a 5 there, we get a minus 6. So we get a 6 is equal to a minus 6. That's not true. A positive number cannot be equal to a negative number. We reject that by writing that x is not equal to 5. When we put a 25 in there, we get a 50. 50 minus 1, it's a 49. A positive square root of 49 is 7. 7 times 2, that's 14. We put a 25 minus 11, that's 14. So the left-hand side is equal to the right-hand side. Of course, for rejecting one solution, you get a mark. For accepting the other, you get another mark. You get a mark for your inverse operation there. You get a mark for getting this quadratic. How many marks are we scoring? 5. Perhaps factorizing there is the last mark, which is a bit extra if you ask me. Okay, so let's do it. 1.2. 1.2 we're solving simultaneously. We're given 3x minus y is equal to 4. This implies that y is going to be equal to 3x minus 4. We can make that equation 1. And we are given a second equation, which is x squared plus xy is equal to 24. That is equation 2. Now to solve simultaneously, you put one into the other. So we're going to say x squared plus x. Where you see y, you substitute with 3x minus 4 equals 24. This implies that we've got x squared plus 3x squared minus 4x minus 24 when you transpose the 24 to the one side. We're just trying to solve a quadratic here. So this is 4x squared minus 4x minus 24 is equal to 0. We can divide by 4. Throughout, we're going to get x squared minus x minus 6 is equal to 0. We can factorize this, which is a technique that is almost always useful. So they will hardly give you things you cannot factorize. But when you can't, use the general quadratic formula. But I think don't overuse the general quadratic formula. Otherwise, your thinking is going to be killed. Anyway, doesn't matter what you choose. It's up to you. So this is a 2 and minus 3. So therefore, our x is a minus 2 or x is a 3. Therefore, we substitute the x values into one of the equations. Y is going to be 3 into minus 2 minus 4. Or y is going to be 3 into 3 minus 4. This is going to be minus 6 minus 4. This is minus 10. This is going to be 9 minus 4, which is 5. Obviously, from just knowing how to substitute in this equation, when you put a 10 on that side, minus 10 is equal to minus 10. If you put a 5 on this side, 5 is equal to 5. So already, if your substitutions here are correct, you know these solutions are correct. But coincidences do occur. You take these solutions into any one of the original equations and make sure they balance out. Okay, so solving this equation into this format is usually a mark, and then substituting one equation into the other. So substituting one equation into the other, is the other mark, and then getting those x solutions, those are the other marks, and then getting the y solutions. Sorry, I don't know, I'm coughing because I'm not sick, but something strange is happening. So we're getting 6 marks, and those are the 6 marks. Pretty great, is it not? Yes, it is. Anyway, let us move on to the next question. So 1.3. Now, as you can see, 1.3 is one of those higher grade questions. Already, from just looking at it, it's not a simple question. But it's a question that is approachable, because what are we? We are maths fanatics, are we not? Now we're told let S equals this bracket here, 1 plus 1 over 7, multiplied by the next bracket, which is 1 plus 1 over 8, multiplied by the next bracket, which is 1 plus 1 over 9. As you can see, the denominators of the next term inside those brackets are increasing by 1. Okay, so that is just a pattern you need to notice. But here now we have some sort of a general term, if you think about it, at the end. This is like doing sequences and series. And then we are told here where m is an element of natural numbers. Now natural numbers is, so if you think about it, natural numbers are those whole numbers 1, 2, 3, 4, 5 up to positive infinity. Essentially, these are positive integers. So this is what we want. And we are being told that m is a value between 30 and 7. Okay, great. Now it says calculate all the value or values of m for which s will be a natural number, meaning s must also be a positive integer. It says now show all the calculations. Okay, so that's easy. We know s is equal to 1 plus 1 over 7 multiplied by 1 plus 1 over 8 multiplied by 1 plus 1 over 9 multiplied by 1 plus 1 over 10. This goes on until 1 plus 1 over m. Okay, that's not a problem. So what do we do here? Well, guys, what is important is to notice that just before this last term, what must have happened here? This could have been 1 plus 1 over m minus 2, for example, multiplied by 1 plus 1 over m minus 1. Then we end up with 1 plus 1 over m. Okay, because we could see that the denominators of the next term inside the bracket was increasing by 1. And to get to that last term like that, it means we must have had a decrease by 1 up until we got m. So this is just a technique you will have learned from sequences and series. This is why a question like this, it's not straightforward. It's a higher grade question. Now, what do we do, folks? Well, what we do here is this. We know that, well, we have to simplify these fractions, essentially. So when the other denominator is 1, I just simply multiply by the other denominator to that numerator. So this is going to be 7 times 1, which is a 7. And then I follow the sign on the numerators, which is a plus 1. So this is going to be 7 times 1, which is a 7, plus 1. That gives me 8. Now you also divide by the same number that you've got. So it's going to be 7 over 8. We can do any technique of solving the fractions. It works out into this. This one becomes effectively 9 over 8. This becomes 10 over 9. This becomes 11 over 10. And then this keeps going. And then if we accommodate these guys, I've just added them because you need to know what happened before you get to that last one. So if you multiply here we're going to say m times 1, m minus 2 times 1 is going to be m minus 2, plus 1 is going to be m minus 1 over m minus 2. And then we do the same here. It's going to be basically m over, because it's going to be m minus 1 plus 1, it just becomes m over m minus 1. And then here it's going to be m times 1 is just m, plus 1 is going to be m plus 1 over m. So this is what we've got. Now notice something here. This, when you're multiplying, this one cancels, that cancels, that cancels, and this one would cancel the next one somewhere. This cancels, meaning that one would have cancelled something up there. So what are we left with out of all of this cancellation? We've got the denominator, because it's 7 multiplied by 1. Then this is m plus 1 multiplied by 1 on the numerator. So we end up with m plus 1 over 7. Okay, great. Now we can see here that therefore our s is basically m plus 1 over 7. So we already have a round number, an integer, a positive integer in the denominator. What should be that one? It has to be a multiple of 7 for it to divide into a round number like that, or a whole number like that, essentially a positive integer. So this means you need to have the logic in your brain to tell you that for you to get a positive integer out of this fraction, since this is a 7, it already guides you that this must be a multiple of 7 so that it can divide 7 into a whole number. So we can say now for s to be a natural number, it is such that m plus 1 must be a multiple of 7, because what is on the denominator dictates how this should go. So, okay. So this is what it is. So this implies that m plus 1 can either be 7. Okay. Now if this is 7, what happens? It means m is a 6, because when you transpose 1, you get a 6. But we're already told that m is greater than 7. So this means this m plus 1 cannot be a 7. Okay, this is what you do on your rough work before you write it down. Then let's put another multiple. This is the 14. Therefore, it means m is going to be a 14 minus 1, which is 13. Or m plus 1 is equal to, now let's see, it's going to be, the next multiple is 21. Therefore, m is also going to be 20. Or m plus 1 should be equal to 28, which is the next multiple. Therefore, m is going to be 27. Now, we can't go to the next one, which is 35, because it's going to lend us to 34, and we're told m is less than 30. So what do we end up concluding? We know that m is an element of these ones. It's going to be 13, 20, and 27. That's it. Can you see? So this is a very nice question. It's a nice higher grade question, guys. So if you love your maths, obviously this one is a good challenge, but if you don't, you are dead. So essentially, simplifying s into that is a mark, right? And essentially recognizing that m plus 1 must be a multiple of 7. It's also important, because that's the logical connection. And then those 3 values, because that's what they wanted. So that's how you score those 5 marks. And that's how you walk away with that 25 marks. Okay, please do the first question within 30 minutes if possible. Then you're going to thank me later for it. All right, let's move on to question 2. All right, moving on. I don't know what is happening. This thing is moving. It's moving. I don't know how to fix it so that it doesn't move without me moving it. Okay, let's continue, guys. We've got work to do. Question 2. Obviously, this is now sequences and series. So we are given a quadratic number pattern. You always get one. You always get one. So 2.1, we've got minus 120. Sorry, let's just write it a bit further. Going to minus 99. Going to minus 80. Now this one is grade 11, guys. And if they put it in this way, you must just chow it. Obviously, with a quadratic number pattern, we know that we've got a sequences of first differences which make up an arithmetic sequence. So let's do, what are those? Going to be minus 99 plus 120. It gives us 21. Then we've got minus 80 plus 99. It gives us 19. And we've got minus 63 plus 80. It gives us 17. So this is easy. And then we do the second differences. We can see here this is going to be minus 2. And the second differences are always constant. Okay, so this one you don't need a second invitation to do it. You just do it. So 2.1.1. We're told to write down the next two terms of the pattern. Not a problem. This is very easy. This is very easy. So here, since we are on this mode, we know that the difference between this one and the next term is going to be minus 2. And then, when we say 17 minus 2, we get a 15. And then we know that this one would be the difference between this term and the next. So the next term here is going to be minus 63 plus 15. Sorry. It gives us a minus 48. That's the next term. And then again, we know that this would give us a minus 2. And then 15 minus 2, that gives us a 13. And then that becomes what would give us the next term. So we get minus 48 plus 13. It gives us a minus 35. So those are the next two terms. So you can work on that diagram or whatever you call that, and then you sort it out and write it here. It's going to be minus 48 minus 35. So that is it. Those are the next two terms. And then, of course, it keeps going. So you get a mark for that because that required an answer only, technically. So 2.1.1, we're told determine the nth term of the number pattern in the standard quadratic format. Again, a very easy situation here. You already know that the second difference is going to be equal to minus 2. And then we know that the very first term of the first differences can be denoted as 3a plus b, okay? And obviously, we also know that the very first term of our quadratic number pattern is actually denoted as a plus b plus c, okay? So these are some of the things that should come quick in your mind, because why not? So we know that 2a is going to be equal to minus 2. Therefore, a is a minus 1. This implies that 3 into minus 1 plus b is going to be equal to 21. Therefore, b is going to be, this is now 21 plus 3, this is going to be 24. Which also implies that A, which is minus 1, plus 24, which is B, plus C is going to be equal to minus 120. Therefore, our C is going to be, so this is now minus 120 plus, not plus, but minus 23. So this is minus 143. Okay? Therefore, our nth term is going to be minus n squared I. It looks like an H. Minus n squared plus 24n minus 143. Now, once we get to this stage, we need to check whether our answer represents our sequence at all. Let's say term 2, for example. We're going to get minus into 2 squared plus 24 into 2 minus 143. We're getting a minus 99. Okay, you can check the other terms. I don't have time. So this is the nth term. So it represents our quadratic sequence for sure. So you get a mark for solving for A, a mark for solving for B, a mark for solving for C, and putting it together. Okay, easy, 4 marks there. Now 2.1.3. So this was 2.1.2. Now we're told here what value must be added to Tn for the sequence to have only one value of n, for which Tn is equal to 0. So as you can see, this is now saying nature of the roots. And we know that we are saying now equal roots, because to say only one root in a quadratic number pattern or quadratic expression, for us to have only one solution, it means we are saying equal roots. So that's it. So we know that Tn equal to 0 implies that minus n squared plus 24n. Oh, by the way, we're saying what are we adding to Tn? So we're going to say we're going to add k, for example, is equal to 0. So now this implies we've got minus n squared plus 24n minus 143 plus k equal to 0. Now we can say for equal roots, it implies that the discriminant should be equal to 0. This implies that b squared minus 4ac is equal to 0. Can you see you're applying nature of the roots in sequences and series? It's very interesting. So these are things you never forget. So again, the coefficient of n squared is going to be a, right? And then the coefficient of n is again b, and the constant term this time is complex. It's going to include k because k is also a constant. So that is what you know is going to be a c. So now when we substitute here, we're going to have 24 squared minus 4 into minus 1 into minus 143 plus k equal to 0. This implies, now what is that? 24 squared, never, it's 576. I would not have known that. All right, this is going to be essentially minus, now it's going to be 4 times 143. So this is minus 572. Now this is a plus 4 times k, it's going to be plus 4k equal to 0. And then this means we've got 4 plus 4k equal to 0. And then what do we know? This also implies that 4k is equal to minus 4. Therefore, our k is going to be minus 1. So we can make a conclusion. Therefore, minus 1 must be added to Tn for Tn equal to 0 to have only one value for n. Okay, that's it, man. That's the nature of the roots type of question. So like I said, if you watched my video that I titled mental preparation, or how to mentally prepare for a maths paper 1, if you missed that video, please find it somewhere. It's going to help you to mentally be ready for anything, and you will start to see these questions are very easy. Only if you are aware. These questions are very easy, only if you are aware of what you need to do. Okay, let's move before we waste time. So what are we doing here? Obviously, for me, to do that expression is very important. And to suggest the discriminant must be like that is very important. And then the correct substitution into some correct formula is important. And your conclusion, because that answers the question. All right? Good. So what you can do, you can test this situation and check if it is correct. How do you do it? You put k in there. When you put k in there, what are we going to get in our expression? We are going to get minus n squared plus 24n minus, now it's going to be minus 43 minus 1 is going to be minus 144 equal to 0. Can you see? Now, when you factorize this thing, of course, we multiply by negative, is going to be n squared minus 24n plus 144. Now, when you factorize this thing here, what happens? It's going to be n minus 12, n minus 12. Can you see? Sorry for that. Essentially, this means there will only be one solution for n, which is going to be 12. There's equal roots. Can you see that? Nice and easy. Nice and easy. What is the other way you could have done this? I'll show you next. Okay, guys, the other way you can solve this is by completing a square on this expression. As you can see the pattern, this is how you complete a square. If you follow this nicely, you'll realize that since this is already a perfect square, meaning there will only be one solution for n over there. It implies that 1 plus k must be equal to 0 for the expression to have, okay, maybe let's put this one. We can say now this implies that for Tn equal to 0 to have only one solution for n, it is such that 1 plus k must be equal to 0. Therefore, k must be minus 1. Is it not so? So you can make a conclusion. Therefore, minus 1 must be added to Tn for Tn equal to 0 to have one solution. Excuse me for my writing over there. I'm a bit in a hurry. So this is what you would do in metric. Okay. Or yeah, say grade 11 because this is a grade 11 question essentially. So these are the two techniques that came immediately to mind. Of course, you can see the other one is a bit labor intensive, the other one is a bit shorter, so you decide what is going to work best for you in solving this problem. All right, let's not waste time, guys. We've got our 4 marks, so let's do question 2.2. We are given an arithmetic series, okay? So this is 9 plus 14 plus 19 plus dash dash plus 124. And as you can see, this is the last term. So that's good. So now it says determine the general term of this series in terms of the form, the normal linear form or standard linear format. So obviously we know that this is a is equal to 9. The common difference is going to be 14 minus 9. They told us it's an arithmetic sequence, so we don't even need to check others. So 9 minus 14 minus 9 is 5. Okay, so this means that Tn is A plus n minus 1 times D. A is 9 plus n minus 1 times 5. This is 9 plus 5n minus 5. This is 5n plus 4. So that is our Tn. Again, check whether the Tn represents the sequence. If you put a 1 in there, it's going to be 5 times 1 plus 4, which is a 9. If you're putting a 2, if you're saying T2, this is going to be 14, okay? And then if you put a 3 there, it's going to be 15 plus 4, which is 19. So you can see that this Tn actually represents our sequence. And we're getting a mark for putting that in there. That was easy, 2 marks. Now, it says, write the series in sigma notation. Okay, so this was actually, this was, yeah, but why don't I just write here 2.2.1, yeah, and then 2.2.2. If we want to write this in sigma notation, we know that essentially the number of terms here. Okay, maybe let's just say we want to know the number of terms first. So we know, we know that Tn is equal to 124, right? And what is Tn? We know that this implies that 5n plus 4 is 124. This implies that 5n is going to be 120. Therefore, n when we divide by 5 is going to be 120 divided by 5 is 24. Okay, so not a problem. So therefore, this means that 9 plus 14 plus 19 plus dash 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 plus 124 is equal to the sigma of 5n plus 4, starting from n equals to 1 to n equals to 24, right? Because we can see the number of terms is going to be 24, and we've got our general term there and the starting point and the ending point. So this is it, guys. This is how you answer this question easily. All we need here is to work out the number of terms. That's important. And then to express this, you're getting your 2 marks. I suppose this is how we're getting our 3 marks. Not a big deal after all. Okay, so let's answer the next question. 2.3 says, given the arithmetic series. Now, can you see here there's a little bit of exponents, so they're making this one a higher order question, but it's actually nothing. It's not what you would really cry about. It says now calculate the value of x if the sum of the first 30 terms add up to 3,720. So this is not a big deal. If they're already telling us this is an AS, we know that for an AS, we know that A here is given as the first term is going to be 2 to exponent x. By the way, this whole thing, guys, I know a lot of you are taught something else. I'm sorry for this, but I have to say it, okay? You guys are taught the wrong maths. I'll say it that way. It's wrong to say 2 to the power x. There's no such a thing, okay? It does not exist. In fact, if you listen to yourself saying it, you're not making a mathematical sense. Why? Because when you read on the rules of exponents, you will know that they say when you're multiplying powers with the same bases, you simply add the exponents. So which means the power is the whole expression. It's not the exponent. I know you guys probably listen to Americans talking about 2 to the power this. You know, Americans always try to be unique. They distort things so that they sound like they are the pioneers. It's not the case, okay? I'm sorry if this one offends someone. It's not the intention, but that's just the reality. You guys are taught the wrong maths. You are actually comfortable with something that doesn't make sense. So I believe we have to try to make things to make sense. Even if we came into these misnomers or misrepresentations or misinterpretations, they are there, of course. But when we can make up for them, we just have to. We can't be people who just follow the wind wherever it goes like a paper. We need to have an identity, don't we? Anyway, guys, please never ever hear yourself saying 2 to the power x. That's rubbish. Okay? It's absolutely nonsensical to say that. That is for your matriculants, but let your teachers say it and everyone else, it's fine. Those people cannot shed their old feathers, can they? But you guys can. You still have a chance. So this is 2 to exponent x or 2 to the index x, okay? Or if you want to read it properly, to read this thing, let me just teach you now a thing or two. To teach you, this is a power. As a whole, that expression is a power, okay? Within this power, we've got an exponent, x. Sometimes this is called an index, okay? Let me tell you this now. I'll never tell you again. This one right here is what we call the base, okay? Now, how do you read this thing properly, mathematically? You are going to say the power of base 2 to the exponent x, or you can say index x. So how you read this, you are reading it as the power of base 2 to the exponent x, not 2 to the power x. Please do not say that. I know there's something we call ordinals or degrees. We talk of the 5th degree power, 4th degree power, 2nd degree power. For example, if you've got base 2 to the exponent 2, this is the 2nd degree power. How do you tell the degree? It's by the exponent. If the exponent is in the order of 2, then you're going to say that is the 2nd degree power. But the whole thing is the 2nd degree power of base 2, okay? Not the other things you guys hear, okay? The 2nd degree power of base 2, because this becomes the signature. Basically, the base is more of an identity of a power. Now, a lot of people make this misrepresentation by thinking, since you are saying it's the 2nd degree power of base 2, because sometimes they say the 2nd degree power of 2, for example. the 2 that you are referring to is the base. And the second degree actually says the exponent is in the order of 2. Okay? All right, okay. Now that I've taught you this thing, guys, I don't expect you to be misled by anybody in this regard. It doesn't matter who, okay? Good. I'm never going to say this again. I'm sorry if this rubs someone wrong, because I know your teacher has probably taught you that way because they themselves are taught that way. Thank God my teacher in standard 7, which you guys call grade 9, made it clear to me that this is wrong to say, and that's why I know. It's not because I am smart. No. I was taught this thing, and I started to look through it as I went along, and it made sense. And it didn't make sense the other way around. All right. Okay. All right. Let's move on, guys. Now we know here that, okay, with all that has been said, whether you feel it's right or wrong, it doesn't matter now. That is our first term. And then what would be our difference? The difference is going to be the next term, 2 to the exponent x plus 1 minus 2 to the exponent x. Okay? Now you know the rules of exponents says if you've got that complex exponent, it means you had 2 to the exponent x times 2 to the 1 minus 2 to the exponent x. And as you can see here, there's a common factor. We can factorize this thing because we've got 2 terms. 2 to the exponent x is the highest common factor. Then we're remaining with 2 minus 1. Okay? 2 minus 1 is 1. 1 multiplied by 2 to the exponent x is just 2 to the exponent x. So this is our d. Okay? So, that's it. Nice and easy. Now that we've got the first term, we've got the common difference. What are we looking for? We're looking for the value of x. So we know that, the sum in an arithmetic series or sequence is equal to n over 2 into 2a plus n minus 1 times d. Okay, that's what we have. And then we are told now here that S30 is equal to 3720. Now, in the part of S30, we know that we're going to have 30. We're substituting into that formula over 2 into 2. A was 2 to the exponent x plus n. So n is 30 again. So this is 30 minus 1 times d. We found that to be 2 to the exponent x as well. This is equal to 3720. Okay. No problems. Now this implies that this is 15 into, now we know that this is going to be 2 times 2 to the exponent x plus, now this is 31, 29 times 2 to the exponent x. Okay, all of that is equal to 3720. Now can you see we've got 2 of 2 to the exponent x and we're adding 29 of the same thing. So those are like terms together. So this implies that we've got 15 into 29 plus 2 is basically 31. 31 times 2 to the exponent x. Okay, I hope you understand what this is all about. But if you don't understand it, it's easy. Okay, it's very easy. Maybe it gets you confused when I'm doing it this way. Maybe let's keep you entertained and say, fine, at this juncture, we want to eliminate 15 so that you can see how to work it nicely before I get you confused. I know sometimes my techniques can create a few problems. Now what we have here, guys, we've got 2 times 2 to the exponent x plus 29 times 2 to the exponent x equals whatever that is. So this is 3,720 divided by 15. We're getting 248. Okay, great. Now again, we can see that we've got a common factor here, which is 2 to the exponent x, but remain with 2 plus 29. Can you see that 31 came from here? You would easily see it if you didn't get scared there. But it's not a big deal, so this is 248. This implies that we can also divide by this business here. 2 plus 29. And then here we divide by 2 plus 29. Just being silly now. This implies that 2 to the exponent x is equal to, now we're going to have 248 divided by 31. It gives us 8. Okay? Now we ask ourselves, can we express 8 as a power of base 2 to some particular exponent? The answer is yes. This is 2 to the exponent x equals 2 to the exponent 3. Or you can say is the third order power of base 2. You get me? Or you can say is the third order power of 2. It doesn't matter. But again, it's a matter of how you read these things correctly. Sometimes it gets a bit technical. Sometimes it can confuse people. So in any case, we know now that when we've got 2 powers on either side of the equal sign with the same base, what do? We simply equate the exponents. So therefore x is a 3. That is it. We've solved it. Now you see, sequences and series, they're applying exponential expressions as well. So this is something you need to know. Anyway, guys, this was not a really complicated case. What is important is finding the common difference here. That's what is important. And then substituting everything into the correct formula. That is what is important. And then the mark is what is important. The rest of the gymnastics, honestly, is maths that you should know. So I don't know why they're giving 4 marks here. It should not be. Actually, it should not be. So I don't know, man. But anyway, this is how they've done it. So maybe we can say you're getting a mark for expressing 8 as 2 cubed. Perhaps. Maybe that's where the mark is. So we're taking our 19 marks, guys. Can you see these are fat marks? There's no need to be losing marks like this because you know what? You are scared. No. Do not fear. Okay, let's charge ahead. Question 3. Now question 3 says we've got 3.1 here. We are given 5 going to 10, going to 20, and wara. And they're telling us that this is a geometric progression. Sometimes I prefer using progression rather than sequence because if you wrote GS, I may be thinking you're talking about a geometric series as opposed to just a progression. But now sequence and series starts with an S, so it's a bit of a situation. Anyway, it says determine the nth term. If this is a GP, already we know that to answer 3.1.1, we know that A is 5. Then R is going to be 10 divided by 5. You don't need to test other values because if you're already told what it is, definitely the 2 consecutive terms will give you a ratio that gives you R when the second term is on the numerator and this preceding term is on the denominator, right? Right, so this is a 2. So we know that Tn is given as AR to the n minus 1. Now, how do you write this? It's going to be 5 into 2 to the n minus 1. And that's it. There's nothing more you're going to do. Please don't make a mistake of multiplying the 5 to the 2 and getting a 10. That's wrong, okay? You have to first deal with this power of base 2 to index n minus 1 or to exponent n minus 1. Not a problem. So this is an easy one. So what was important was finding the common ratio essentially. But they're just giving you 1 mark. Okay, not a problem. Maybe 2 marks would have been fair. 3.1.2. What is the next question? It says calculate the sum of the first 18 terms. Now we know that Sn is going to be a into r to the exponent n minus 1. Why do you choose that? It's when the common ratio is greater than 1. You use this formula. When the common ratio is less than 1, you use 1 minus r to the exponent n, okay? Either way, you will still get your answers correctly, even if you used the other formula. So this implies that S18 is going to be, now a is 5, into r is 2 to the exponent 18 minus 1, all over 2 minus 1, okay? So let's do that one. So we've got 5 into 2 to the exponent 18 minus 1 essentially. And then we've got this number here, 1310715. 1, 2, 3, 4, 5, 6, 7. So this is 1,310,715. Yes, ipelele is complete. That's what our former president said. Technically, what are you doing here? You're getting a mark for the correct substitutions and a mark for the answer. Nice and easy. So 3.2. It says the first and the second term of a geometric series, can you see, is given as, so that is the first term right there, and that is the second term, respectively. Determine the value or values of x for which the series will converge. You will always get a question on a convergent geometric series. Easy. So obviously, if this is the first and the second term, we should know for a fact that a, do we need a? No, we don't. We need r here. We know that, well, for a convergent series, for a convergent GS, it is such that r must be less than 1, greater than minus 1. This implies that minus 1 is less than, r is going to be the next term, which is 4x squared minus 16, divide by the first term, which is going to be 2x minus 4, okay, less than 1. So this is just what you set up and you move on. So what do we do there? Okay, all right, we know that in the numerator we've got a difference of 2 squares right there. So basically, if we factorize that thing, we're going to have here 2x minus 4, 2x plus 4, all over 2x minus 4, less than 1. So you can already see here, there's a common factor between the numerator and the denominator. And what do we end up with? This says 1 is less than 2x plus 4 less than 1. Therefore, we transpose now. Okay, let's not rush. This also implies that when we transpose this to this side, we get a minus 3 is less than 2x, which itself is less than, when you transpose that, we get a minus 3 this side. Are we serious now? Aye, that was a minus 1. Yes. See, mistakes, Baba, mistakes. When you see things that don't make sense, please interrogate them before you continue. Don't be overly excited. You've got a solution. Make sure that solution is solid. Now, this is going to be, this is going to be minus 4 minus 1. It's going to be minus 5. Therefore, now we divide. X is going to be less than minus 3 over 2. Remember, when you divide by a positive number, the sign doesn't change. So the inequality remains. So this is minus 5 over 2. And that's it. That's it. That's it. That's it. Bafowethu. Is one. It's done. So this one is a very easy question. A bit of algebra still. Nothing serious. I don't know why they're giving 4 marks. It's ridiculous, is it not? Because you're getting a mark for the substitution, obviously, and maybe for the rest of the substitution, I guess. And then for this format, you're getting 2 marks. That's how you get 4 marks. The rest is your problem. Okay. Now we're told here in 3.3. I was supposed to finish this within an hour, but I took longer because you know what? Sometimes the man talks too much. A convergent geometric series has the first term of 2 and the common ratio of 1 over the square root of 2. It says now calculate sum to infinity divided by S2. So obviously sum to infinity divided by S2 is going to be equal to, the sum to infinity is A over 1 minus R, okay? Then we are dividing it, so we just expand that like that. S2, how are we going to deal with this one? Okay, let's just write the formula. It's going to be A. Since R is less than 1, it's going to be A into 1 minus R to the exponent N over 1 minus R. Okay, great. Now let's deal with this mess here. A is 2 over 1 minus the square root of 1 minus 1 over the square root of 2. Okay, divided by A is still 2, 1 minus, this is 1 over the square root of 2, but this one is squared. Okay, maybe let's put square brackets there. All of that divided by 1 minus 1 over the square root of 2. Okay, so you know that when you're dealing with fractions, you flip the other one. I mean, when you're dividing, 1 minus the square, this is going to be 1 minus the square root of 2. All of that divided by 2 into 1 minus the square root of 2 rather squared. Okay, you can see that this guy and that guy and this guy and that guy are doing the things that can happen. So all we are left with is 1 over, basically this thing here is going to be 1 minus, when you square this, it's going to be 1 over 2, right? Right. This is the same as 2 now. Is it not so? I don't want to prolong the inevitable, because 1 divided by a half is just 2. Okay. Not a problem. Okay, guys, that's easy. Not a big deal. So that was a bit of an exercise, I suppose. So for me, it's substitutions, and the final answer. The rest is your own endeavor. You're walking away with a cheap 10 marks. Here they were just very friendly. As you can see, most of the time, questions on the geometric sequence or series are very easy and pretty straightforward. But be careful. Situations do occur that demand a little bit more attention from you. Now let's get to the fun section, which is functions. All right, guys, let's enjoy question 4. This is now grade 11 again, grade 11 functions. So we are given f of x equals 2. Guys, for detailed analysis of this type of questions, consult the channel on any long, or should we say full question paper I have done on functions. You will understand. But anyway, it's almost like a compulsion. From here, we can see that our a is greater than 0, because a is always the numerator of that function. This tells us that our graph on a Cartesian plane should be in the first quadrant and the third quadrant, okay? Meaning these functions are decreasing in nature, right? Because as you scan this from the left to the right, these graphs are forever dropping to infinity. So this is essentially a decreasing function if you ask yourself. This is something you will not be told normally, but it's something you need to be aware of. So this is a decreasing function. Okay, just in case you didn't know. You see, sometimes I'll keep dropping extras as we go along. And then, of course, these are the asymptotes. This is the horizontal asymptote. And the opposite of this sign, makes us our vertical asymptote. Okay. Okay, good. So that is just a quick analysis you need to do. Please, guys, don't skip these steps when you're sorting these things out, or you will be surprised how a simple question can take you down. It says now write down the equations of the asymptotes. Easy. You take this denominator x minus 1, you equate it to 0, and then you solve for x. So x is going to be equal to 1, y is minus 2 as it appears. Okay, that is easy. Easy to marks there. 4.2 says draw the graph of f. Clearly label all the intercepts with the x's and the asymptotes on your graph. That's easy. Now we need to solve for the x and y intercepts. Okay, easy. So we can just simply say for y intercept, it is such that 0, lying. It is such that f of 0 is equal to 2 over 0 minus 1 minus 2. What is that? This is 2 divided by minus 1. It's minus 2. Minus 2 minus 2, it's minus 4. So we can say, therefore, the y-intercept is going to be 0 and minus 4. It's very easy. It's very easy. And then again, for x-intercept, it is such that we have f of x equal to 0, which implies that 2 over x minus 1 minus 2 is equal to 0. This implies that 2 over x minus 1 is equal to 2 over 1. We transpose that 2 and then we cross multiply. This implies then this times 2 is going to be 2x minus 2 is equal to 2 when you multiply 1 by 2. And then what we can see here, this implies that 2x is going to be equal to, transpose this as a 4, therefore x is a 2. Therefore the x-intercept is going to be 2 and 0. Okay, good. Now, what is the next step? The next step is to do this one now. We know that we've got our x-intercepts, we've got our asymptotes, our things are finished. So now let's draw the graph. Okay guys, so there is our graph. I've already drawn it quickly. I didn't want to waste time. So that is as simple as that. So showing that x-intercept, or any one of the intercepts, it's important. Showing any one of the asymptotes is important. And of course for the shape of the graph. Normally you score 3 marks for that. So what are they showing here? 4 marks. Hayiwena. Ufuna ukwenzani? Ufuna ukwenzani? So I believe the other mark is probably for the y-intercept then. It's fine. Okay, so let's move on. Next question says 4.3. We are meant to determine the equation of the line of symmetry of n for which the gradient is less than 0. So I know that that equation is going to be y equals minus x minus 1 minus 2. So this is using the shorthand techniques. When you FOIL out, it's going to be minus x plus 1 minus 2, which is going to be minus x minus 1. Nice and easy. But you can use your long method, take the intersection of the asymptotes, and then work out what this line would be that passes there, which is this gradient we're talking about, okay? So it's really up to you, but when you understand how to use the equation of the function to find the equations of the asymptotes, it's very important. This is built on that y is going to be equal to x into x. Is it minus p? Yeah, I'm not too sure. It's minus p plus q, something like that. And then the other one is y equals x minus p plus q, the positive gradient one. So this is what I know makes life a lot easier in case you don't understand. So these are the x's of symmetry. When you are given the equation, so this is the one we were looking for, the one with the negative gradient, and as a result, we just do that. And you know that these are part of what you have on the equation. When you substitute, you solve it nicely. So this is just as easy as ABC. So you're getting 2 marks like that, and you move on. Okay, so 4.4 says, for which value or values of x will the f of x be be less than or equal to 4? So, equal to minus 4. Less than or equal to minus 4. Basically, this means it's either at 4 or below 4. So this is only in that section. Okay? Can you see that segment? This is where our x is less than or equal to minus 4. So basically, x here must be, remember this is an asymptote, must be less than 1, but greater than or equal to not minus, but we want the x values 0. Because at 0 y is minus 4, then we want the negative side, which is just this little bit of an interval here. It's that interval we're looking for, okay? Our friend is acting up. So that is how you interpret that. Nice and easy. No big questions around it. You move on. So for the format, you usually get 2 marks. So this was an easy 10 marks. Really nothing serious here. So let's just move on without wasting time. So we've got question 5. Now again, another grade 11 function related question. I told you the graph of G is a multiplied by base 1 over 5 raised to exponent x. Can you see that? Minus 5. Okay, so this is a vertical shift, as you can see. Passes through A. Okay, there's a point through which this graph passes. It says now show that A is 1 over 25. That's a very easy question. First of all, you write what you are given. G of x is going to be A into 1/5 to the index x minus 5. Okay. Now, we know that 5.1.1, we are given again, you just write it as it is. A into 1 over 5 to the exponent x minus 5. Now through point A, you just substitute that point that we are being given. This is minus 4 equals A into 1 over 5 to the exponent minus 2 minus 5. Okay, great. So this implies you transpose the 5, becomes a plus 5 minus 4, it's 1 equals A to the 1 over 5 all to the exponent minus 2. So what do you do here? You divide by this business here, 1 over 5 to the exponent minus 2 over 1 over 5 to that exponent minus 2. This one cancels. Therefore, we know that our A is going to be When you move this into the numerator, it carries a positive exponent. So this is basically going to be 1 over the exponent 2, which is essentially, I just want to write it here, it's going to be 1 over 25. That's easy, né? Okay, you can use your calculator also if you feel like this is overwhelming, but be comfortable using the exponential laws and rules whatsoever, because that is what makes your brain to start questioning certain actions that you may end up taking. Anyway, so what is important here is to substitute into the correct equation. Okay, that is what is important. And essentially, even though the answer was already given, but I guess it's fair to give you a mark for it, because as for the gymnastics, it's not such a big deal, is it? No, it's not. Okay, so here we incorrectly labeled our answer. So this is just 5.1. Then we've got 5.2. It says now determine the coordinates of the x-intercept of G. Now this is easy. For x-intercept, it is such that G of 0 is going to be equal to A, we found out now it's 1 over 25, into 1 over 5 to the exponent x, because that's what we're looking for, minus 5. Okay, all right, okay. What am I doing? Did I say G of 0? No, man, it's wrong. It means 0, 0, 0, 0. Now we transpose the 5, we get 5 is equal to 1 over 25 into 1 over 5 to the exponent x. And then we can effectively divide by 1 over 25. We divide by 1 over 25. Sometimes do the math, folks. Now what is that? This is going to be the same as flipping this 25 times 5. This is 125 over, let me just double check with my calculator before I start feeding you guys poison. I don't know, guys, I'm not moving today. Yeah, it's strange. Maybe because it's a long time that I've done this thing, you know. Now I can already feel I'm a bit stagnant. Yeah, it's 125 equal to, so now what are we going to do here? This is going to be, now we can just write it as a negative exponent. This is 5 to the exponent minus 1. All of that to the exponent x. I'm trying to get somewhere, okay? Can I express 125 as a power of base 5 raised to a particular exponent? The answer is yes. It's 5 cubed equals 5. Now the rules of exponents says if we have a power like that with an exponent and an exponent outside, so simply you multiply the exponent. This is going to be to the minus x. Now if the bases are the same on those powers on either side of the equation, we simply equate the exponents. Yeah, this was imply, man. I don't know what is the story now. This was meant to be implies. This implies that 3 is equal to minus x. Therefore, x is equal to minus 3. So therefore, the x-intercept is going to be minus 3 and 0. Nice and easy, eh? Nice and easy. So again, a bit of flavor of dealing with exponential rules. But if you feel overwhelmed, use your calculator. You will get it right. Okay. All right. Okay. So essentially for this big statement, it's very important. And essentially, how many marks were they giving here? 3 marks. Wow, that is ridiculous. It's not correct. Okay, maybe we can give you 2 marks for the answer. It's fine. Why not? And then let's move on. 5.3 says given h of x is this situation now. Can you see? H of x is similar to g of x, except that we are missing a now. A has become 1, and we've taken this graph back back up by 5 units to cancel that minus 5 units. Can you see? Now it says determine the equation of the inverse of h in the form y equals. Okay, easy. H of x is equal to 1 over 5 to the exponent x. Now we know that, well, the inverse of h of x is such that we switch these two. So it's going to be x is equal to 1 over 5 to the exponent y. In this case, we are forced to introduce logs, but it's very easy, man. I don't know why I'm doing it the long way. X is equal to y. Okay, I'm making a mistake now. If we introduce logs, it's going to be log x equals log of 1 over 5 to the exponent y. This implies that log of x is equal to y log 1 over 5. Maybe because we are revising, let's just do that, and then you solve for y. You divide by this 1, then that cancels. Therefore, we can just make a conclusion that y is going to be, if the bases are the same, this is the same as log of x to the base 1 over 5. Okay, I don't know why I put it in brackets. I don't need to. Of course, a math student knows that this is a question worth just 2 marks. They can easily just, by inspection, you don't need to show the calculation. By inspection, you just do that. Nice and easy. Okay, great stuff. Otherwise, if you did the calculation, switching those two and the final answer is what is important. But a question that says determine, as you would know from what I told you, you can do it by inspection or by calculation. If you did it by inspection, you still get full 2 marks for the answer. All right, okay, all right. So that was 5.3. Oh, this thing always catches me out. Ne? So this is 5.3.1. So let's do 5.3.2. It says, describe the translation form. Describe the translation from G to H. Can you see they are saying the translation, meaning the horizontal and vertical shifts. What did we do here? Okay, if you look at G of x, it was 1 over 25 into 1 over 5 to the exponent x minus 5. If you solve this, this is the same as 1 over 5 squared times 1 over 5 to the exponent x minus 5. Can you see that? Rules of exponents say if you've got the same power, powers with the same bases multiplying together, you simply add the exponents. So this is 1 over 5 to the exponent 2 plus x. Okay, right, minus 5. Or you can even switch that order and say x plus 2. So basically the 2 is missing here now. This 2 is missing and this 5 is missing. So what did we do? It means we subtracted 2 there and then we added 5 here. Oh, I don't know what this thing is doing now. What did we do, guys? Ooh. It means we added 5 here and essentially we subtracted 2 from there, so that we end up with h of x. So if this is what we did, remember guys, this is not the answer, okay? This is your thought process. You don't even have to show this thing. Trust me. Then you know that you want to compare these two and see for h of x to be like that, it means we shifted this graph to the right. Remember, when you subtract 2 from x, it means you're shifting this to the right by 2 units. And when you add to the y values, it means you are moving it up by 5 units. So all you can do here now to answer that question is to just take down this thing, because this was your thought process in your rough work. This is not necessary. Okay, so you can just simply say here, h of x is the graph of g of x translated to the right. Oh, Nkosi yami ndabhala kakubi. Davele ndabhala kakubi ne. Okay, let me try to relax, even though time is against me. So this is the graph of g of x translated to the right by 2 units and up by 5 units. Easy. Of course, you've got your thought process right there. So you can wrap this off, because this is what helps you to determine what happened here. And that's it. So you score your 2 marks there. The 2 units to the right and the 5 units upward is what is important. Again, an easy 9 marks, guys. Nothing really serious there. Let's get to the one that sometimes can cause a few issues. The parabola. But the parabola should be already a question a lot of you guys are comfortable with, because the parabola is like the Bab and Flace of maths. Okay, so let's deal with the Bab and Flace of mathematics. Now it says the sketch below represents the following graphs. Can you see? This is given in the standard format, meaning it's a hypothetical graph. We have to find out from the sketch what is going on. And the graph of G. So the graph of G is given completely. So we're not guessing anything. But what can we learn from the graph of G? We know that this is a +2. I don't know if you guys can see there. This is a +2. So that means that's the y-intercept. So meaning here we've got 2. Okay, that is the most important. And then we can work out B, which is the x-intercept. You transpose the 2 to -2. You multiply by the 2, you get a -4. So that means there at B, we've got -4. These are the things you can quickly do. As you can see here, it looks like the axis of symmetry passes at that -4. So the graph of G gives you a bit of the characteristics of the graph of F. Okay, now we're told the line of symmetry, can you see, cuts the x-axis at B. Done. We've sorted it. Which is also the x-intercept of G. Can you see that? Very important information. C, which is -2 and 0, is the x-intercept of F. So this means C is this point over there. Okay. D, which is 0 and -12, is the y-intercept of F. Again, this is very easy and clear. Okay, so now that's all we are given. Forget about the rest. So we can see that, well, from what we can see, A is also an x-intercept of F. But we don't have enough to say something about it. Okay, now we have to account for these ones. You see the ones that we just inferred to. You see this -4. We've got to account for it. These two, we've got to account for it. Even though they are quite obvious, you're not just going to show up with them. You will have to explain how you got them. Let's go on. Calculate. See, the question already dictates. Calculate the coordinates of B. It's very easy. So, 6.1. We know that B is the x-intercept of G. You're going to use what you have enough information on, such that we know now that a half of x plus 2 is going to be equal to 0. This implies that a half of x is equal to -2. Therefore, x is -4. Therefore, B is the point minus 4 and 0. Remember they said coordinates, so easy. So this statement is very important because it follows in substituting that nicely and then eventually giving us what we want. Nice and easy. No need to panic there. So when you can flow, just flow. Determine the equation of f in the standard format. Now that's a bit of work. Okay, great. Not a big deal. So we know the turning point, right? Okay, we don't know the full turning point. We only know one coordinate, the x coordinate. So we can't use that. We can't use that. So we have a bit of a situation, don't we? Yeah, we look like we're in trouble now. We've got the y-intercept. We've got, we only have the axis of symmetry. Okay, now let's think about it for a second. So what do we do, guys? Well, let's have a look what we can do. Look, we know that this distance from B to C is the same as the distance from B to A, because this is the axis of symmetry. So meaning that distance is equal to that distance. So since we know this is a horizontal distance, we've got coordinates of C and we've got 4 at B, B being the average of these two. So we can actually work out the coordinates of A. So what we need is to say A is such that 1. How do we get that? Look, guys, we've got options. I mean, you can use analytical geometry knowledge if you want. It's very easy because, I mean, sometimes you need a technique to build on to the other. It really doesn't matter how you really want to go about this. But for me, I want the coordinates of A because I want my life to be sorted. So the coordinates of A is essentially going to be the coordinates of A. How do we do that? Lord. It's going to be x at A. Okay. X at A plus x at C over 2. Of course, this one will come as a surprise. It's equal to the x at B. Same story. I mean, the y is 0, so we know that we are not interested in the other one. So, okay, maybe let's do it. Y at A plus y at C over 2 equals the y at B. Let's just apply. Now we are doing maths. So why not? Why not? X at A is what we are interested in, plus the x at C is going to be a minus 2 over 2 equals minus 4. All right, this is basically 0 plus 0 over 2 equals 0. So we can say therefore our A, cross multiply, that's minus 8 plus 2, it's minus 6 and 0. Okay, so if we get the coordinates of A, which is the x-intercept, why am I doing that? I want to say therefore my f of x is going to be A into x minus the first root into x minus the second root. Yeah, man, that is how it goes, this thing. And then this means A into x minus the first root, it's going to be plus 6 into x minus the second root, it's going to be plus 2. Can you see? And then after this, we know that point D also lies on the graph, and that's what we need. We substitute there, it's going to be minus 12 equals A into 0 plus 6 into 0 plus 2. And then we want to solve for A here. I'm just not going to prolong this. So this is 12. So 12 divided by, it's going to be minus 1. And it makes sense because that's a grumpy face parabola, right? So it means a must be a negative number. So we can say, therefore, f of x is going to be equal to minus 1 into x plus 6 into x plus 2. Now we need to do it in this format. So we solve this thing. It's minus 1 into, we FOIL x squared plus 8x plus 12. We multiply with that, it's going to be minus x squared minus 8x minus 12. And that's it, guys. So however you want to do this, it's up to you, really. So it's very easy, man. It's very easy. It's very easy. What do we do now? Well, I guess we're getting a mark for getting this guy. It's very important. And to substitute into this format, it's very important. To substitute that point is very important. And eventually to get the correct equation, that is how we get those 4 marks. It's very easy. And we have shown everything. Of course, you can explore other ways you can solve this. There's no time, guys. We're losing time, actually. So I'm going to try and finish this as quickly as possible. Now, if f of x is, so they're confirming that we are correct, determine the coordinates of G. If FH, the vertical length between the points of intersection of F and G, is a maximum. Can you see that? Very great. So what are we looking for? The coordinates of G. And you can see G is on the x-axis. So we don't mind. Once we find the x value there, it's important. So first of all, let's look at FH. FH is the parabola, which is minus x squared minus 8x minus 12. Okay, maybe let's do this. This is f of x minus g of x. Is it not so? Yes, because FH is basically the vertical distance. So the parabola is above the straight line. This means it's minus x squared minus 8x minus 12 minus into a half of x plus 2. Now we solve this. It's minus x squared minus 8x minus 12 minus a half of x minus 2. Now we've got minus x squared minus. Now if you solve these two like terms, minus 8 and that, so you just multiply that, it's going to be 16 minus 1 is minus 17 over 2x, and then this is going to be minus 14. Now they told us that this distance is a maximum, so we can say now for a maximum distance, it is such that fh prime is equal to 0, right? Now when you do the derivative here, it's going to be minus 2x minus 17 over 2 is equal to 0, and this implies that we've got minus 2x equals 17 over 2. Therefore, x, can you see we're getting the value of x there? So therefore x is 17 divided by 2 divided by minus 2. So x must be minus 17 over 4. Okay. So what is 17 over 4 is basically minus 4,25. And this is the correct position because we already have a minus 4. So that makes sense. So we can say now, because they said determine the coordinates of G, we can say G is the point minus 17 over 4 and 0. Because point G is right on the x-axis. Okay, easy 4 marks, guys. A bit of applications of calculus here was necessary. Otherwise, we were going to have a few issues. But remember, if you didn't want to use calculus, from this equation you can complete a square. You will be able to tell what would be the maximum distance, because the constant term would give us the maximum distance. And effectively, you would be able to work out what x should be. Anyway, anyhow, let's not waste too much time here. We don't have it. So let's see. We're getting 4 marks for this. Doch, I think getting this equation is important. And doing the derivative here, it's important. And of course, this expression is important. And the final answer. The rest is gymnastics. You should already know. Yes. Let's do the last question. 6.4. Says for which value of values of x is an x value multiplied by f prime, meaning the gradients of f, is that product greater than 0? Okay, not a problem. So we want x values, meaning the x-axis basically, multiplied by the gradients. F prime means gradients. Of f, okay? So look at the gradients of f. On this side, we've got positive gradients, right? And then at the turning point, the gradient is 0. So valently 0, I'm not romantic, okay? And then this side, the gradients are negative, right? Okay, that's it. And then the x values are positive and negative going away. So let's see what happens. Now, we want a product that is greater than 0. This means on this side, you can see the x values are negative. So negative times positive is going to give us a negative. So this means all the way up until this level, this is wrong because we're not interested in that. But can you see from this point on, let's just say up until the x-axis, up until the origin, what happens? The x values are negative, multiplied by the gradients are also negative. So negative times negative is equal to a positive. So this means we will have a situation here where the gradients are negative and the x values are negative. They multiply to a positive. But this will only happen from, let's just do this. This will only happen in this interval from B to the origin. Because now the x values on the other side are positive, the gradients are negative, and that product is less than 0. So that means going this way and to the origin, we are not allowed. So this is the correct interval for which this is satisfied. So we know that x must be less than 0, but x must be greater than -4. That's how easy you answer this question. Okay, guys, you get 2 marks for the format. It's nice and easy, né? Not a big deal. Again, an easy 12 marks. So they kind of made it easy for students on this one. Now let's do the money. Okay, guys, we have to do our finances so that we can be rich, né? Our finances will make us rich if we're aware. Now, question 7 says, convert an effective interest rate of 11.3% per annum to its equivalent nominal rate per annum compounded quarterly. Okay, this is a grade 11 question essentially. So this is 7.1. We know that 1 plus effective interest is going to be equal to 1 plus this I, which is nominal, over the compounding period to that exponent m. I don't know if you write it like that, folks, but I don't remember it. Please double check this thing. Okay, sometimes my brain just shuts down. So this implies that 1 plus, now we've got what is this thing here? We've got 11.3%. Actually, I'm disturbed by the message, that's why I'm now fiddling. So 11% is basically, okay, 11,3 is going to be 0,13. 11, come on calculator, 11,3 divide by 100. So I want to write it as a decimal. So it's going to be 0,113. Okay, so you just convert that to a decimal. Equals 1 plus I, which is what we want, over m. Now we're saying quarterly, so this is going to be over 4, and then in 1 year it's going to be 1 times 4 quarters, which is just 4. From this situation, what do? We're going to have to eliminate this whole thing, so we just do an inverse operation. If we have this to the exponent 4, we're just going to take the 4th root, and what you do on the one side you must do on the other side. Okay, great. So this implies, let's just do the 4th root of what we have there. So what you do there, you press shift and then that exponent button, which is x to the something, then you put a 4 there inside, you go to that number 1 plus 0,133. 113. Yabona ubatla humpolayish. So this is basically 1,027126,161. Please guys, just have the patience. And then of course you're going to have 1 plus I nominal over 4 essentially. And then what do? We transpose the 1 to the other side. This is going to be 0,0271 equals I nominal over 4. So obviously we just cross multiply this thing here. Okay, therefore our I nominal is going to be whatever we have here is going to be 4 into this number 0,027126,161. Then we multiply by 100% because we want this thing in a percentage. So we subtract 1 from that, we multiply that by 4, then we multiply that by 100%. It gives us a 10,85%. Okay, to 2 decimal places. Of course, the instructions, the general instructions, don't forget them. Where necessary, you leave it to 2 decimal places, so you follow that instruction. This was an easy calculation otherwise. A correct substitution into the correct formula. Not necessarily the gymnastic. It's not really that great, is it? Yeah. One way. So essentially multiplying this by 100 is the other mark. The rest goes to the answer. Yeah. Because doing this is very important. If you don't do it, you might find yourself in the code. Okay, let's get to 7.2, guys. I don't want to waste time. This is a very simple section and it's pretty straightforward. Now Lisa opened a savings account. So once you hear savings account, think of a future value calculation. And deposited 10 scordos immediately into the account. So this means on T1. Now a timeline is important, folks. I cannot overly emphasize the importance of this thing. At T0, this lady already decided, but Lisa these days can be a man as well, which is, hey, yeah, whatever, man, it's fine. She or he deposits that 10 scordo there. This is immediately at term 0. She deposited that amount. And then that is an immediate deposit, right, into the account. Then the account paid interest at 5.3% per annum, compounded monthly. Okay, so there is our interest for the whole time period. She keeps this money in the bank. It's paying at 5.3% per annum, compounded monthly. These are things you want to make sure they're in front of you. Then she started making additional monthly deposits of 500 rands into the account 3 months after. Can you see? So this means she skips T1 and then she skips T2. And then on T3, this is when she's paying a 500 rands. That is a drade 5. You understand me? Okay. So technically she's going to continue paying this drade 5 now all the way. Okay, she's going to be paying the drade 5, continuing. And we don't know until when. Okay, so she says now her last monthly deposit of 500 rands was made 5 years later after this account was opened. So 5 years is basically T60, because monthly is going to be 12 times 5, which is 60. So that means she makes the drade 5 deposit at T60. Of course, this means the whole shenanigan has been continuing. So a timeline, folks, is crucial. But now pay attention. This was a lump sum that she just dumped into the bank, and then this one was monthly payments up until the end of those 5 years. So it's critical to understand what is going on. So a timeline will always clarify everything. Now it says how much money was in the account 5 years after the account was opened. Now you have to think about two things. The 10,000 rands spent 6 terms, because it says T1, 2, 3, 4, 5, 6, 7, wara until T60. Again, if you wanted to know the period, you'll take this and subtract that, and then you add 1. So this one goes for 61 terms actually. These are going to be 61 terms for this one. No. It's just 60 terms. Actually, it's just 60 terms. Not 61, because we're not going another month further. So it's just going to be 60 terms for this one. Okay, all right, okay. I'm thinking now, am I doing the right thing? But why do I feel like, what is the story now? Let me just make it short. Let's say we had 4 terms. How many terms would she have waited? It's 1, 2, 3, 4. Yeah, it's going to be 60 then. Okay, so always try to make it easy and understandable. If you see this is too long, cut it short and see what happens when you make an immediate payment. Then do you have to worry about that? Stuff like that. So basically, the amount of money that she has, this lady, is going to be, we're going to say her future value is going to be essentially the 10,000 rands. I don't know, man. Do you write a formula here? Yes, it's ridiculous, is it not? Okay, maybe let's write a nice formula. This is going to be, let's say P into 1 plus I to the exponent n, right, plus, because we are going to have that 10,000 going for those 60 terms, plus we are going to have this dude here. We're going to have this dude here, which is going to be now our future value calculation is 1 plus I to the exponent n minus 1. I don't know, guys. This one is a bit complex, but I hope you will understand. Now, this is the what? 10 scordos into 1 plus the interest is the same, but now you convert this to decimal. It's going to be 0,053. Ne? Let's just double check. 5,3 divided by 100. It is 0,053. And now this is over 12 because we're doing it monthly. And how long is it going to go? Like I said, if we just had 4 terms here, we would have 1, 2, 3, 4. So if they are 60, we're going to have 60 here. Plus, what is this question again? Yeah, how much money was in the account 5 years after? That means exactly at 5 years, okay? So, not a month after, so that's good. Then now the x here is going to be the 500 bucks that we're adding here. 0,053 over 12. Now, how many is this? Now, remember, we started paying this one on that month. So, basically, it's just going to be the difference here, right? Because, like we said, we're going to say this minus that is just going to give us 60. So, 60 minus 3 is what? So, 60 minus 3. So, we're going to take this and subtract that. It's going to be 57. So this is going to be to the exponent 57 minus 1. So guys, be careful of these calculations. They look simple, but they can teach you if you're not exercising caution. Okay, so let's see how much money this person is going to have. I hope your calculators can handle this. Mine can. So this is going to be 10,000 into 1 plus 0,053 over 12 into the exponent 60. Actually, what am I doing? This is 10,000. Yeah, I messed up now. Plus 0,053 over 12 to the exponent 60. Then to that we're adding this one. 35 into 1 plus 0,053 over 12. That raised to the exponent 57 minus wait a minute, I'm lying to you guys and you are quiet. Nina zonbulala. Yeah, man, I think it's correct. I think it's correct. But there's an extra payment though. This term will give us 57, but we have to add 1. Why do I feel like it's gonna be 58 backwards? Is it 57 or 58? Because we have to count this amount as well. Because there's gonna be 57 terms plus 1. Yeah, that's gonna be 58. Okay, bafowethu, be careful, eh? Always, but again, adequate practice with these things will make sure you don't make a mistake. Ne? But if you don't practice adequately, you will always be found wanting. As Julius Malema would tell you, he will tell you that you will be found wanting comrades. So 0.05, I went 53 divided by 12. Ke masiboneni ke bafowethu ukuthi sinamalini la. Ayitheni yancinci kangaka le mali. Just 45,000 I went. Are you kidding me? Hayi andiyithembanga ke le mali. Khawuthi khona ingxaki. 10,000 into 1 plus, I don't know guys, I kind of lost my focus over there. something is not adding up here. Something is not adding up here. 1 plus 0.053 over 12. You know, sometimes when something doesn't make sense, you just double check it. You just have to. 0.053 divide by 12. And if it is what it is, then it is what it is. Your height, it's small. 5 years. I fit 45,997. This investment is weak. This is 2-3. You win. Gag. Waste of time. I will really mal. Why in these 5 years, Ngabuphinde was save even more than this nonsense. 45,997 rands. Anyway, it's fine, Bafwats. Equally, because the 500 rands is technical. Let's understand that. Cool. So at this 5.3% is quite small. What gave you a bit of an edge is that. So it's not a bad idea, but yeah, a weak investment technically. Now, what are we getting here? 5 marks, folks. So essentially, this calculation on its own, it's important. And this calculation on its own is important. This calculation on its own is important. And these terms, Bafwet, are important on their own, okay? Because the rest was kind of given to us. So that is how we score those 5 marks. And let's move on. 7.3, we are told here, Sam wants to buy a house, okay, and takes out a loan of 860,000 rands. So a loan, you're talking about a present value calculation. He can only afford to pay 7,200 per month, starting 1 month after the loan is granted. Obviously, just respecting that grace period. Now the interest rate is compounded monthly at 9.5% per annum. Calculate the number of payments that Sam will make to repay the loan. Okay, all right, okay. Again, guys, I cannot overly emphasize the importance of a timeline. Even though you may think it's a waste of time, for me, it helps me to think more constructively about this, because this shenanigan can be very confusing. So this one is paying 7 squad or 32 there, and then continues to pay that 7 squad or 32, and then this goes on and on and on and on until TN, which is what we want to know. Is it even going to be 7,032? Yeah, we don't know. Let's just leave it now. Sometimes the situation can be a little bit serious, It can be serious. But anyway, let's just say, yeah, maybe 7,032, probably, most likely. So now we are getting this at 9.5% per annum, compounded monthly. Guys, don't take these things for granted. Do these things. They will help you. Now we want to know what is N here, essentially. Who are you, say? You are the one we are interested in. Not a problem. We know that the present value calculation says we've got x into 1 minus 1 plus I to the exponent minus n, all divided by I. Easy. Now, folks, I don't know how you like to do this. For me, substitutions in financial maths, maybe, but I don't like to complicate my life, but let's just do it. So we're going to put 860,000, sorry. is equal to 7,200 into 1 minus I is 1 plus, this is going to be 0,095 over 12 to the minus n, because that's the guy we're looking for. I don't like to substitute at this stage for such a calculation. It is often ridiculous. But as ridiculous as it is, sometimes for substitution you get marks, so maybe sweat a little bit. What can you do? There's nothing you can do, man. Okay, 9,5. I just want to confirm my 9,5. You know, sometimes I've got trust issues. Now, what do you do, guys? You know that the gymnastics is that you're going to take this and multiply it there and divide by this guy to break this bracket. Once you do that, you transpose this bracket to the other side and you transpose whatever you would have here to this side, so that it's 1 minus whatever you've got. Ne? And then you introduce logarithms. So for me, I know that n is going to be equal to minus the log. I'm moving fast now. The base is going to be this expression right here. This expression right here becomes the base. Of course, if you have not been practicing, you won't know. So this is what would be the base of our log. So this is going to be 1 plus 0,095 over 12. And then the number is going to be 1 minus that whole shenanigan you would have had this, which is going to be 860,000 times, maybe let's put it this way, times this 0,095 over 12. And then all of this shenanigan is divided by the 7 squared root 2. So if you know this, it's easy for you guys, because I mean, you're going to end up wasting time writing forever here. You just need to know. So this is minus the log. Now you've got a nice log function there. It's 1 plus 0,095 divided by 12. And then the number is 1 minus 860,000 times 0,095 over 12. Okay, divided by 7,200. Okay, so now what I'm getting here is 369, 2, 1, say 3. Again, so this is a bit of a situation. So now this will multiply by a month, okay? Yeah. So technically, I don't know what we do here, but if we're paying this 369 and then there's a, it just says this little decimal here is suggesting that there will still be another payment. Obviously, it's going to be smaller, okay? Because of this little small decimal, it means we're going to pay our 7,200 squares that are full for 369 terms. But there will be one last term where we will be paying something smaller because there is a decimal. So essentially, in total, how many payments, even if we don't care how much, in total the payments are going to be 370. Okay. Okay, so that is just how you think about this, guys. Again, you need to be practical at some point, because if you just focus on the numbers, you will not really get the full picture of what is going on. But if you just take those numbers into something meaningful, you will get somewhere in life. So it's going to be 370 payments. But we know that the 370th payment is not going to be a full 7,200 because there's a decimal. It means it's a smaller amount. It's fractions of that which we are paying. I hope we are clear, guys. And n cannot have a comma. Please, if you putting an answer for n, it has to be a whole number, because remember, n is an element of natural numbers. Right, there are no decimals there. You always have to round off to the nearest. But if we were to round off to the nearest, we'd have to discard this, but this is a payment. But it's just a smaller payment than you would expect to pay. So in a practical or real life situation. Anyway, guys, the substitution into the correct formula is what is important. Number one. Number two is essentially getting that interest. That interest in that format. Usually the nominal interest is important. And the answer. Sorry, it's 3 marks. Maybe, just maybe, to say the gymnastic of introducing logs, because you should not, it should just be 3 marks here. But let's move on before we waste time. So this was 7.3.1, because this is 7.3, okay? Now let's do 7.3.2 and finish this business of money issues. It says now, how much will Sam pay in the last month to settle the loan? So this basically says last payment. Now this is again a very interesting question. Actually, there's a student who asked me to do some financial maths videos for him or her. I did them, but unfortunately the modes of transmitting those videos to them didn't work out. So I don't know if I did correct by not posting them on the channel. I kind of felt I should post those videos on the channel, but I thought, what if that is a case study or case work, or should we say some kind of work that they're supposed to do for school, and then they goes public, then it becomes cheating. So I kind of panicked and didn't post it on the channel, but I could if they want, because I still have those videos. So hit me up if you're watching here and you are the one who requested those videos. I actually have them, but I'm just not sure whether to post them in the channel or not, in case we cause trouble. But if that's no trouble at all, just hit me up or give me a signal. I will post them so that you can learn all these techniques, because I kind of felt those questions were very good for this purpose. Okay, now the last payment. Guys, remember, after we've paid 369 payments, there is going to be a 0.21 some change there. Now my problem with that is this one. Those decimals, maybe it was fair to write them all. So let me start again. Now I gave myself a steep hill. Oh Lord, oh Lord, oh Lord, oh Lord. Why did I do that? Why did I do that one? 860,000 multiplied by 0.095 over 12. We will do it with what? 7,200. So, I win. Where is this bracket now? How? So let's just write it all now. Let's just write it all. This is 2, 1, 2, 7, 6, 7, 9. It's important to leave it out like that. Rounding it off is actually dangerous. Just round off to the nearest. Now the reason is I'm doing this one because we're going to say now the last payment is going to be the future value, the present value of the amount that remains that is going to accumulate interest for 1 month. So we can just say, well, the last payment is going to be the present value that we are going to get to be accumulating interest for just 1 month. Ne? But now what is the present value? It's x into 1 minus 1 plus I to the minus n, I win, all over I. This is going to accumulate interest for just 1 month. So this is how you do the final payment, but make sure that P is the present value. It's not just the principal. This is just the present value. Okay, just going to use the present value calculation. Now, what are we doing here? We are going to do this. This was 7,200 essentially. It's going to be fractions of that 1 plus minus. Then this is going to be 1 plus 0,095 over 12. I'm sorry guys for the small writing. This is going to be to the exponent minus. Now remember, when we've paid these 369 payments, what remains is 0,2127679. So this is what we have there. So this is going to be 0,2127679. Okay, so all of that we are dividing. Maybe let's move it because it's going to be creating issues for us. Don't worry that my equal signs are starting to drift apart. Unfortunately, I don't have a choice here. So this is 0,095 over 12. I'm a bit careless now, guys. You will forgive me. You know, sometimes it gets to you. You sometimes just get it and you're like, yo. So this is how you do it. I'm just using my present value calculation. I find it easy this way. Now let's just go for it. So we've got 7,200 into 1 minus 1 plus 0,095 divided by 12 to the exponent minus 0,2127679. Okay, all right, okay, and then we close this. We divide this one by 0,095 over 12. And then that whole shenanigan, we're multiplying it by 1 plus 0,095 over 12. So your calculators, folks, are the best, I'm telling you. So this is the amount of money this guy is going to pay in the last month. So it's going to be 1,500, 310. I win. This is 1,536 rands, 69 cents. Can you see it's a small amount than the 7,200? Okay, so money, you only round off to 2 decimal places, whether you like it or not, okay? Money does not have more than 2 decimals. Okay, all right, okay. So this is easy, guys. I applied my present value calculation smartly. So this is, you become creative as well as you go along to suggest that you have a full understanding of this thing, and at the same time trying to save time from just jumping around like it's the first time you do maths. Okay, all right, okay. Now what do you do, guys? Here, this calculation is important, that calculation is important, and this answer is important. And we can say here, maybe we're giving you a mark for that situation. And essentially, why 5 marks, man? Come on, guys. Just come on, okay? Maybe we can say the extra mark is the entire general substitutions right there. But I mean, it should not be so much. There are areas where they are squeezing you. There are areas where they're giving you more than you should be given. Anyway, guys, I'm sure you can see financial maths is a bob and flace type of a section. But if you don't pay attention to tools like timelines, you will be suffering, okay? Please master them. Master how to interpret information you are given into a timeline, and also know a few tricks to get things done correctly. Otherwise, this thing can be pretty easy. it can be pretty easy. Okay guys, let's move on. All right, Bafwetu, let's move on. So let's remove what is not necessary and keep moving. So we're doing question 8. Now question 8 is easy marks. Please. This question must never cause you any pain. Of course, they are trying now to ask extra questions there, which are actually just the cubic function being asked in question 8. Otherwise, there's nothing there. So please, no marks should be lost in this section. So 8.1, it's a standard first principle. So we're given f of x equals 1 minus x squared. This implies that the first derivative is going to be the limit as h tends to 0. So this is just this nasty little thing here. It's going to be f of x plus h minus f of x over h. Okay, please, that formula must be in your head. This is the limit as h tends to 0. Now let's try to substitute. So we've got 1 minus, now we're going to put, instead of x, we're going to put x plus h, and then we square that. Then we subtract that whole shenanigan, 1 minus x squared. It's as simple as that, over h. Not difficult. I don't understand anyone who doesn't thrive on this one. So this is 1 minus, when we fold this out, it's going to be x squared plus 2xh plus h squared minus, maybe let's leave it for now, just one last step to go. So this is the limit as h tends to 0. Let's sort this out. So this is 1 minus x squared plus minus 2xh minus h squared minus 1 plus x squared over h. Now we've got like terms that will take care of each other. If this doesn't happen, just know you didn't do something right. Okay, those guys take care of each other. So we get the limit as h tends to 0 of minus 2xh minus h squared all over h. Okay, here you're just writing a lot of the same thing. Now we can factorize this by taking the highest common factor, which is h on the numerator. So we remain with minus 2x minus h all over h. And then now these two take care of each other. And then what do? We're going to have 2 minus 2x minus 0, which is minus 2x. And of course, if you used your power rule there, you would actually realize that this would be minus 2x, because the derivative of a constant is 0. So this is sorted, folks. It is sorted, nice and easy. Just that you are taking the long route here. So what is important here is actually substituting into this formula. Okay, all right, okay. And then essentially eliminating things here is important, and factorizing there, it's important. And essentially the final answer, 1 2 3 4. Okay, and then that substitution of 0. Now eliminating the h tends to 0 part. So this is how those 5 marks are actually scored. I don't even know why I started marking that. I normally don't, because I feel like it's not necessary. The student should know here what to do. Okay, we're supposed to find the derivative of 3x squared minus 2 over x. Okay, so this means we have a derivative of 3x squared minus, you never leave the x on the denominator, so this is going to be 2 times x to the exponent minus 1. Now we can do the derivative using the power rule. There is going to be 6x minus, when you multiply by 1, there's going to be plus 2x to the minus 2. Now this is safer. Just leave it like this. Don't complicate your life and change that to a positive exponent. It's not necessary. Easy 3 marks here. So basically writing this in that format is important. And then those 2 derivatives of each term. Sorted. No issues. Easy 3 marks. And then 8.2.2 says, now we are to do the derivative in terms of y over x of y equals the square root of x into the cube root of x minus 5x. Okay, now first of all, we need to sort y. We can't use this when we've got these issues here. So what we do, we take this one into x to the 1 over 2 into, now this is x to the 1 over 3. Ne? Yeah. This is how you convert to those things. So this is 5x. Now that we have this in order, we can do FOIL method. Multiply there. This is going to be x. Again, you're multiplying powers. Those are the powers with the same base, x. What do? You simply add exponents. So a half plus a third, what is that? Let me just use my calculator now. I don't want to think, okay? So 1 over 2 plus 1 over 3 is 5 over 6. Okay, minus. Here again, we're going to have 5x. Now this is just going to be 3 over 2, right? Right. So this is 0, I when 0, I when hey 0,5 plus 1. Yeah, it's 3 over 2. So now that we can say therefore dy over dx is going to be, we use the power rule again. So this is going to be 5 over 6x to the exponent minus 1 over 6, okay? Minus, this one is going to be 15 over 2 x to the exponent a half. Okay, so sometimes don't overly use your brain during the exam, you're going to die. Again, it is safer to leave it here. Don't convert anything to other things. So you sort it out and you leave it like that, okay? Easy, guys. So if there's any mistakes, which is possible, please take them with kindness. Yeah. So you're getting a mark for that conversion and that conversion, right? Right. And then we are getting a mark for this derivative and that derivative. Right. Maybe we can just distribute these marks a bit better. And say for whatever you did here, the conversions, you're getting a mark. For simplifying that, you're getting a mark. And then you're getting those 2 marks for the final derivatives. Again, this was an easy 12 marks. Of course, time is trying to run away from us, but I think we can make it up when we have questions as easy as this one. So let's do question 9. Question 9, we're told here, the graph of f of x is equal to ax cubed plus bx squared and has stationary points at P. So meaning point P is a turning point. Once they say stationary points, this means turning points. Okay? And at the origin. So again, this is the turning point. Okay, good. So we're essentially given turning points of this cubic function. And what do we notice? We can see that this a here is greater than 0 because our graph is something like that. Can you see the shape is telling the story? So we know that if we ever had to find the value of a, it has to be a positive value. Now this question says prove that a is 1 over 12 and b is minus 1 over 4. All right, okay, all right. Now, how do we start answering this question? 9.1. Here we're going to have to apply calculus, né? Because without doing that, we're not going to get anywhere. Because this can be quite hectic, okay? So let's see. If f of x is given as ax cubed plus bx squared, what do we know? We know that the first derivative of x is going to be 3ax squared plus 2bx. Ne? That's what we know. So we need that, first of all. Now, second of all, we know that if we use any one of the stationary points, the gradient is 0. So we know for a fact that f prime of 2, for example, is equal to 0. Don't worry, this coordinate is the y coordinate on the actual graph. But we know that when we substitute the x value at the turning point, it gives us the gradient of 0. So that's why we're writing a 2 there. So this implies that now we're going to have 3 of a into, we put a 2 there squared, plus 2b into a 2 is going to be equal to 0. This implies that we've got, this is going to be 4 by that is going to be 12a plus this one is going to be 4b is equal to 0. Okay, now you can see that, okay, this is a particular equation. It's an equation that I don't know, man, but what do you want to do here? You want to leave it alone, do you? Yeah, you can make this one equation 1. Let's see if we can find another one, because this is definitely going to need simultaneous equations. Okay, all right, okay. But we know for a fact that f of 2 is a minus 1 over 3. Nah. Yes, we can see that this point, we can use that point to our advantage twice. Because we can use it on the derivative, we can use it on the original function. This implies that a into, now we're putting a 2 cubed plus b into a 2 squared is going to be minus a third. This implies this is now 8a plus this is going to be 4b is minus a third. Now, can you see we've got two equations that look something like the other one? Now, we've got two techniques that we can solve this. I mean, you can see here, if you can see that there's 4b, you can actually use the elimination techniques. You can just subtract one from the other because you can make this equation 2. Let's just apply that technique for just, just for fun. Otherwise, you could easily make one the subject of the formula. But if you can see there's a common thing, you can eliminate it. You can just say you're taking 2, or let's just say 1 minus 2. What do we get? We get 12a plus 4b equals 0. Then we're going to subtract this one, which is going to be 8a plus 4b equals minus a third. And then you put your nice line over there. And then what do we get? 12 minus 8 is going to be 4a. All right. And then we've got here a situation. This one will subtract and make us 0. So it's going to be now 0 minus, actually I didn't put the brackets correctly. The bracket is the whole thing, okay? So 0 minus a third is going to be a third. Okay, therefore a is going to be a third divided by 4. This is definitely 1 over 12. We're done with the a. Therefore, we can just substitute the a value into any one of the equations we choose. So we know that therefore 8 into 1 over 12 plus 4b is minus 1/3. Okay, you're putting the a value into 1. So you can just say put a equals 1 over 12 into 2. That's if someone is asking questions, because some people like to ask questions too much. Sometimes it's obvious, you know. And what are we going to do here? This is the same thing as 8 over 12 plus 4b is equal to minus 1 over 3. I don't know why I'm dragging. 4b is equal to, this is minus 1 over 3 minus 8 over 12. Therefore, b is going to be equal to, just use your calculator, guys. Sometimes don't prolong the inevitable. You're just going to sweat for nothing here. Okay, it's 1, and then we divide that by 4. So we're getting minus 1 over there. Then when you divide by 4, it becomes minus 1 over 4. So we've sorted that. Okay, so whatever other technique you think is going to be useful. Of course, this was a bit of an essay. If you look at it for just 4 marks, it's ridiculous. But anyway, what is important is doing the derivative there and understanding that this situation is going to land us there. Okay, that's the first 2 marks. Or even you may just forget about that and say no. What is important is that equation, and essentially this equation. How many marks? Just 4. I win. So slanyela. Wari hlanza jwale. Hayibo. Kanti kwenzeka ntoni apha? Hayi, asazi ke nathi. That means doing this gymnastic, it's important then. The derivative and then doing that gymnastic and then getting, yeah, but I was actually correct, man. The values, we already knew what they are, okay? We already knew what they are, so it's not important technically. But this equation is important, yeah. 3 marks. And then the 4th mark is essentially substituting the a value into one of the equations. Those values are already volunteered to you, so a bit of a scary 4 marks there. Okay, excuse me for that, folks. I'm a little bit uncomfortable now. 9.2 says, for which values of x will f of x be concave down? We know that we know the x coordinates of the turning points, so it should be halfway between those turning points. So it's going to be somewhere there. So that is the average. So we can say this is when x is equal to the average. Of course, not equal to. Remember, on this graph, this one becomes concave down below the x coordinate at the point of inflection. So we can just say this one has to be x less than. The average between those 2 turning points is going to be 0 plus 2 over 2, which means x must be less than 1. That's it. Don't complicate your life here doing derivative of a derivative and finding f of x. You're just going to sweat for nothing, folks. This is just 3 marks. Easy stuff, you know, very easy stuff. So you can simply say, this is good. You can get 2 marks for the answer. It doesn't matter. Or you can do the things that can be done and waste your time. At this point, it's injury time, boss. Injury time. The x-coordinate at the point of inflection is the average of the 2 turning points. Done. And you know that less than that, it's going to be concave down. Above that, it's going to be concave up. Easy, ne? 9.3. Determine the equation of the tangent. Sorry, this question is always there. Sometimes they push it to question 8. Sometimes it is where it's supposed to be. So let's just quickly run through it and see how well we're going to do it. And then we're looking for x at -2. So what do we know? We know that we have the point and we have the equation for the gradient. We can just deal with that nice and easy. And then at that point of tangency, those 2 points, the tangent and the graph are equal. So we can find the corresponding y value at that point. So we can say now the point of tangency is such that we've got f of -2, which is, we don't have f. We didn't do the things that we were supposed to do, but in any case, we've got f indirectly. So we know that the a value is 1/12. So this is 1/12 into the x coordinate now is -2, sorry, and then we are cubing it. Plus b, we got actually -1/4. So this is -1/4. And then the x is -2, and then that was squared. Easy, ne? Yeah, because we're just taking that, just substituting the values, because to try and waste our energy, we will be dying and for no reason. 1/12 into -2 squared, I cubed. When 10 wenza izinto ongazithunywanga nje. Oh, Nkosi yami le nto. Yandiqhela. 1/12 to -2 cubed minus -1/4 into -2, that one squared. So this gives us a -5/3, okay? Therefore, that point of intersection or tangency is going to be -2 and -5/3. We need that point, right? We definitely need that point. Because they gave us the x coordinate, we need to find the corresponding y coordinate. But what do we know? We also need to find out the gradient of the tangent. So we can say m of the tangent. Maybe let's write our essay the way we know how. We can say, but we know that the gradient of the tangent is going to be f prime of -2, because that will give us the gradient. Again, f prime, we didn't try to get an equation, so it's going to be 3a. So it's going to be basically 3 into a, which we found it's 1/12. And then we're going to put the -12, and then we're squaring it, right? So guys, I'm sorry, I'm doing it in a very clumsy way, but I'm tired now. If you don't follow, you don't follow. But I'm using this equation, basically. I'm using this equation. So I'm just substituting the values I know to try and simplify my life. Okay, so this is going to be 2 into b, we got -1/4 into x, which is -2, right? Yes. So let's find out what is this tangent. But it should be a positive gradient, I suppose. But let's see. 3 into 1 over 12. Okay, guys, it's going to be a bit of a calculator work here now. Minus 2 squared plus 2 into minus a quarter. Into minus 2. See that minus 2 gives us two things, the gradient. The gradient is 2. Can you see it's a positive gradient? You can almost tell that it's somewhere there. So it's fine. We can see that. Not a problem. So we can say, therefore, the equation of the tangent is such that y is equal to 2x plus c. Ne? Then through that point of tangency, I will call it POT, point of tangency, which was minus 2 is to minus 5 over 3. It will be such that minus 5 over 3 is to 2 into minus 2 plus c. Therefore, c is going to be 4 minus 5 over 2. I don't know what is that now. It's 5 over 3. All right, so let's deal with it. It's going to be 7 over 3. Therefore, y is going to be equal to 2x plus 7 over 3. Nice and easy. Okay, that was a bit of a silly question, but it's important to understand a few points because the point of tangency is important, getting the gradient is important, and essentially the equation. We're getting 4 marks. Okay, maybe this substitution that amounts to the 4 marks. Great. Okay, so easy 4 marks, guys. We just had to do a few little sayings, and then from those little subtopics, I mean, it's like writing an essay. So if you're writing an essay, this is a math essay. You continue being in conversation with your marker so that they follow what you're doing. At times, it makes it so nice, man. They may start giving you marks you don't even deserve. Oh, just because you seem to be doing it right. Let's do the last question before we lose too much time. At least we did well. 9.4, it says, use the graph to determine the values of k, for which, now you can see this is the equation of f, but k here is a vertical shift. Okay? Because it's a constant. Now, this must have 3 real roots, meaning it must have 3 intersections or 3 x-intercepts. Okay? So we want 3 x-intercepts. At the moment, we only have 2 at the origin and there. But now, if you look at this graph, when we look at it in this manner, let's just try to do it. I love these applications, brah. So there's our graph. Now let's move it. So now we have our graph there. So for us to have 3 x-intercepts, can you see there's 3 x-intercepts now when we leave it there, because it's going to be here, it's going to be there, it's going to be there. But as we move further, we lose those x-intercepts. So this means we cannot move beyond the vertical distance from the x-intercepts to this turning point. Okay? Otherwise, if we move exactly that distance, we lose the third x-intercept. We only have 2. And then if we move beyond, we end up with 1. So even if we move down, can you see we lose all x-intercepts? Okay, we only get 1 x-intercept over there. So the technique is we have to move this one up, but not enough to get to the x-axis, just within this distance, like to move it over there, for example. If that is the case, we can see we've got an x-intercept, we've got an x-intercept, and an x-intercept. So it's a bit of a nice one. So our key to answering this question is this vertical distance. Even though this is minus 1 over 3, this is just a third. So how can we move this one up? Obviously, we need to add it. And for us to add it, we're going to say k must be less than 0, right? Because it has to be a negative number so that when we put it in there, it becomes a plus. And of course, less than 0 meaning the x-axis or the the origin. But this one has to be greater than this distance of minus a third. So it has to be greater than minus 1 over 3, because that means we're moving it up. So easy, ne? This format gives you 2 marks. Guys, there's nothing here. These guys were just given a bit of a break. Now, this is time up, folks, unfortunately. Only because, I like to indulge a bit and talk a lot more than I'm supposed to. But we only have 2 questions to go, so let's just try and squash them quickly. Question 10 is the optimization type of question, which is easy, so please guys get your marks, but this one can horrify anyone. Now, in the sketch below, ABC is an equilateral triangle, meaning this side is equal to this side and equal to that side. Okay, an equilateral triangle has all the sides equal. 2, the angles are all 60 degrees. So guys, here, like I told you, the mental preparation video, I took a paper 1 examination. I tried to highlight to you what are the things you need to successfully answer questions, any type of question in those sections. So please watch it, because I cannot give you everything all the time in the same way. Otherwise, you will not be thoughtful. So, let us move, guys, before I start talking nonsense. It's just 2 questions. Now, we are told here that with a side AB, there is AB, which is equal to m units. So this side is actually m units. Okay, that means all the other sides are m units. Now, DEGF is a rectangle. What do we know about a rectangle? Now, you need to know things, boss. You need to know things. The opposite side are parallel and equal to each other. And the same goes for these ones. Okay? And they are essentially equal to each other as well. And also we know that the corner angles are 90 degrees. Okay? Now, like I told you, the mental preparation for this type of a question is to know everything, even geometric figures. Otherwise, you're not gonna win. Now it says prove that the area of the rectangle DEGF is. Okay, so our focus is on the rectangle. So our focus is on this rectangle. Okay, now how do we deal with this one? Yeah, I forgot. They gave us extra information here. That BF is equal to GC and it's equal to X units. So BF, this distance here, is X. And it is also equal to this one here, which is going to be X. Okay. So this is good. This is good because we're going to work our magic just right, just right. Essentially, this says we need to find this distance right here. Because if we find that distance, as you can see, this is m minus 2x, right? because the whole length is m. When we take out these two x's, we get that distance. And that means this side is also m minus 2x. Great. Great, great, great. Now, the other issue that we need to find the area of a rectangle is to find that distance. What is that distance? That is EG or DF. What is that? This is just the task that we need to do. But as you can see here, now look at this little triangle, the yellow one. We've got x and we want that side, and we've got an angle 60 degrees. Can you see? We can use the tan to find DF. So this is what you need to do to answer this question. 10.1. To answer 10.1, we can simply say, basically, we can just simply say AB is equal to BC. Why? We know that triangle ABC is an equilateral triangle. You just show it like that. Okay, maybe let's show it better. So in an equilateral triangle, all sides are equal. Okay, so what are we looking for? We're looking for BC. So we know that this is M equals, because AB was given to us as M, but now BC is made of BF plus FG plus GC, okay? Which is going to be M equals, BF is X plus FG, which is what we want, plus GC, which is X. We can say therefore FG, which is what we're interested in, is equal to M minus 2X. Can you see? Of course, I was writing those easily, but you can't just show up with the answer. You've got to show us how you got this one, because it's very important. Okay, that's number one. That means we've got a side of our thingies. We can say but, okay, we know for a fact that angle B, we can say angle A is equal to angle B equal to angle C equal to 60 degrees. These are angles in an equilateral triangle. Okay, let's write it better. These are angles in an equilateral triangle. They are all 60 degrees. What are we writing to? We can say this implies that in triangle DBF, nice and easy. What can we say there? We know that the tangent of 60 degrees, okay, maybe let's write it better. The tangent of B is going to be equal to DF over, this is the opposite of adjacent, which is BF. Okay, that one you don't need to provide a reason, it's just a trig ratio in a right angled triangle. Okay, because they told us that this is a square, this is a rectangle. Those corner angles are 90 degrees, so angles on a straight line will make 90 degrees. So sometimes it gets complicated, so whatever you do. This implies that tan of 60 degrees is equal to DF, which is our interest, over X. Then we just cross multiply that. We can say now that DF is equal to X times tan of 60 degrees. Now this is done nicely and easily. Can you see? They are hiding the fact that this question is heavy. You would think it's just a walk in the park. No, it's not. It's actually heavier. So they are hiding that this is a high order question. So sometimes you will think by just looking at the marks, this is easy. Sometimes when you see big marks, It's not even difficult. It's just that there's a lot of things you have to say which are just in front of you. But sometimes they put smaller marks. Sometimes they put smaller marks so that you can think, this is easy. And then the next thing you're choking and you're like, why am I choking? It's because you're not aware, okay? Anyway, now we can say then the area of DEGF, okay? Did they write it that way? Is going to be equal to length times breadth. The length is FG times the breadth, which is going to be DF. Can you see that? This is now M minus 2x into, okay, maybe let's do this, into x times tan of 60 degrees. Then let's simplify this thing. We can see that, we can start with that one. This is x times tan of 60 degrees is root 3, okay? Into m minus 2x. Now to write it in the way they did, you can just switch the two positions. This is root 3 times x into m minus 2x. So that is sorted, guys. Just like that. Nice and easy. Okay, so this was a bit of an essay, obviously. And obviously they want everything shown. So sometimes it happens. So what is important, guys, is this business right here. It's very important. 2, this is very important. I don't know. There are just too many things here that need to be appreciated. But maybe we don't need to give a mark for this one. But perhaps the mark is for this one. It's important. And then we can say here, what matters is using the special angles to get to this business. Because the rest is straightforward. The answer was already given. But you can see there's a lot of work that you need to do before you can say the stuff that you want to say. Okay, let's go to 10.2 before we lose too much time. I don't want to go beyond 30 minutes on this other half so that it's not too much for you guys. Now it says determine in terms of M, the maximum area of the triangle. The maximum area of the triangle. Now that is a bit silly, is it not? Okay, all right. So the triangle we're talking about is the big triangle. It's not a problem. Now what we need to do here, the area of a triangle is half base times height. But we can't use that, can we? We are going to use the area rule. Because we know the angle, the included angle, we know the sides. So we can say area of triangle ABC is going to be half AB times BC times sine of B, isn't it? That is the area rule. Then let's see, this is going to be half of AB, it's M, BC, it's M because it's an equilateral triangle times sine of 60 degrees. Now, this is half into M squared. Sine of 60 is root 3 over 2, right? And then we multiply everything else. It's going to be root 3 times M squared over 4, right? That is that one. So it says determine in terms of M the maximum area. So now we can say for maximum area, it is such that the area prime is equal to 0. Okay? Now I'm trying to think now, what are these guys doing? So let's do it anyway. So we essentially have root 3 over 4 times M. In fact, now we multiply this by 2. Okay, let's see. When we derive this, we multiply that by 2 in front. 2 takes out the 4. It's going to be root 3 over 2. M is equal to 0. Ingathi sizoba nezinkinga ke manje. So it means M is 0. Now if M is 0, theni ngathi ngokuyasimosha nje wena. Utheni ngathi ufuna ukungimosha nje wena. I'm trying to think, guys. Now, what am I missing here? Because my problem here, when they're saying maximum, I feel like I have to find M. But now, if I'm supposed to do this in terms of M, then it's ridiculous. It means my answer is the top one. So we don't need to do the derivative because it becomes 0. And the maximum area is just not going to work. If we're going to say in terms of M, I suppose we leave this one here. But now as to why it's 4 marks, I don't understand. So yeah, that is the story. So I don't understand. My goodness. Of the rectangle, not triangle. Okay. So sometimes I know when you get to these sections, you will feel like you're dead. So it's okay, guys. Mistakes, okay. Okay, the maximum area of a rectangle. So you can say for area max, it is such that the area prime is equal to 0. So what is that area? It's root 3 times x into m minus 2x. Okay, what am I doing here? I'm causing trouble, am I not? Yes. Let's forget about, let's first simplify the area. We can see that the area of the rectangle was given as root 3 times x into m minus 2x. So obviously we need, because we're going to need to derive here, so we're going to FOIL this out. It's going to be root 3 times x. Okay, maybe let's put m before x. So it's going to be m x, because we want to do this in terms of m, so we have to eliminate x, minus 2 root 3 times x squared. Then we can say for maximum area, it is such that the area prime is equal to 0. Then when you take a derivative of this, it's going to be root 3 times m, x gets eliminated, minus this one becomes 4 root 3 times x is equal to 0. And then we solve for x. Then this is going to be minus 4 root 3 times x equals minus root 3 times m. And then we divide by 4 times root 3. Oh, gosh, yeah. 4 times root 3 divide by, actually minus, minus 4 times root 3. Sorry, guys, I'm getting a bit throaty now. It's a bit of a situation, and then the root 3 cancels. So we know that our x is going to be m over 4. Now that is fine. And then we can say, therefore, maximum area of DEGF is going to be equal to root 3 times x is basically going to be m over 4, right? Into m is m over 4 minus 2. No. What am I doing, man? Oh, dog. Looks like this question is starting to box me now. Minus, I'm worried about my time, actually. That's why I'm panicking now. So we want to substitute into that original. So it's 2 into m over 4. Okay, good. So let's simplify here. This is going to be root 3 times m over 4 here. All of this, we can sort this out. It's going to be m over 2. So this is going to be 2m minus m over 2 here. So this is basically root 3 times m over 4 into m over 2. So this is going to be root 3 times m squared over 8. Yo, yani. If there's mistakes, guys, please forgive the guy. The guy feels a bit boxed now, and I'm worried I have lost so much time. I am not happy. I'm not happy with Msalufa. Anyway, whatever is the story, this is the story. So we started by answering the wrong question, and that's why we end up in a hurry, out of commission. Anyway, folks, 4 marks, doing the derivative here is important. Solving for x is important. Substituting x in there is important. And the answer. Done. That is what matters at this point in time. Okay, so you're taking that 7 marks. So it's actually fairly easy. It's just that I answered the wrong question. Sometimes your tiredness will get to you. Okay, let's quickly do question 11. I am so tired now and hungry. Question 11 says, given the probability of A is 0,3, probability of B is 0,43, and probability of C is 0,18. Once you are given 3 things, think of a Venn diagram of words, something like that. But sometimes it's not a big deal because we don't know much. We are told here, though, that events A and B are independent. Now that is cool. So if they're telling us that events A and B are independent, it means these ones have an intersection. A and B. This is the story. That means they will have an intersection. And we are told events A and C are mutually exclusive, meaning A and C does not intersect. So basically, we can say C probably does something like this. Maybe. This is just the thought, okay? In case we need it. We have already thought about it. Meaning A and C do not have an intersection. That means B and C are likely to have an intersection. It's possible. Or maybe C and B are not, but at the moment we can say safely, probably, this is possible. But let's just do this because we're not too sure that C actually has anything to do with B, but it does not have anything to do with A. That's what it's telling us. But it may do it indirectly through B. It's possible. So always think of a Venn diagram when you're given 3 events like that. But at the moment, we're not interested in a lot of things. It says now, events A and B are independent, meaning the P of A times the P of B is going to be the P of A and B. You know, the product rule applies for independent events, which is why we know this intersection will exist. Okay, that is why we know. Okay, Now we're told here, okay, that these two are mutually exclusive, meaning the probability of A and C is 0. Okay, this is also a very important statement to know, that the probability of A and C should be 0. Okay, maybe let's write it a bit better. So when these two are mutually exclusive, it means the probability, the probability of A intersection C is 0. That is the message being sent to us. So these are the things, guys, to always come on. I cannot overly emphasize the importance of that video that I showed you. This is not for me to have views, that you go and watch that video so that it gets views. It's for your own good, okay? I'm doing this for you only. I really don't care about myself in this regard, but I care more for you folks, that you do better. And not just do better, but to understand the things you do. You don't want to be going through the motions and realize later you're in the wrong bus, or that you wasted your time. You could have done something else. You want to make sure that as you continue pressing, you know that it's only because you understand where that thing is taking you. Okay, let's not talk too much. It says now, what is the probability that A and C will happen simultaneously? We've already answered it by analyzing that statement. So we've got 11.1. So we've got 11.1.1. We know that this is 0. Or you can even write standard box. 1 minus 1 problem. It says now, what is the probability that at least it's either A or B? Okay. So at least is basically the probability of either A or B will take place. Now, we were told these two events are independent, so we can use our addition rule here. So this one is going to be equal to the probability of A plus the probability of B minus the probability of A intersect B, because we're told these two are independent. So our product rule is sorted, and therefore it can answer the question for us. So PA or B is going to be PA plus P of B minus P of A intersect B. Easy. The probability of A was given as 0.3 plus the probability of B is 0.43 minus here. These are independent events, so meaning the product rule applies. That is going to be the probability of A, which is 0.3 multiplied by the probability of B, which is 0.43. Easy. So when you understand what you're given, trust me guys, this whole thing becomes a piece of cake, and you start to ask yourself, why are they asking these lousy questions now? Are they trying to suggest I am weak? Because you will feel as strong as a bull. Anyway, so remember this one set to 2 decimal places. So this is 0.60. So we leave it at that. But for word 2, it was an easy question, not needing too much. Essentially, the general substitution is important, but this calculation was not given. It's important in the final answer. That's how you score your 3 marks. This is grade 11 work otherwise. So no need to be sweating here. So 11.2. Sorry. We are told a group of 250, so the totals are important. Grade 12 learners participated in a survey, some questioning. They were asked if they used the social media TikTok. Oh my goodness, that is a rubbish application in my opinion. People are being crazy. They're more than they have ever been crazy elsewhere. They're doing all the ridiculous things, trying to go naked, kids and old women. It's disgusting, actually. And men, yeah, you can see though, to be honest, you hardly see men. It's only those stupid men who are there, who are always trying for attention. I mean, those are just useless men. You wouldn't take them anyway. Of course. There are some things there. There are some educational stuff that you can find on TikTok. There's a Miss Angela. Is it Miss Angela or somebody? That woman is people you would want to perhaps watch on TikTok because they're giving you important things in a fun way. That is good. I'm not saying she is good because she is her, but I'm just applauding what is a good thing. She doesn't go there and display destructive behavior and, just for trends. She's just giving good stuff in a very fun way, which for me is good. Then there are other guys who are posting some short videos of educational stuff. That is a strong message. I don't want to talk about the other stupid things people say in that application. In fact, for me, my attitude towards the application is just negative. Anyway, who cares? I'm just a village pumpkin and I wouldn't understand those things anyway. Anyhow, let's go. The results are represented in the table below. Can you see? You will see that mostly it's girls who are being foolish on that thing. Can you see? 105 women against 68 boys. Can you see? Women are there and they are really crazy there. It's ridiculous, man. You're taking your respect from us for you guys in the shit that you're doing there. Anyway, anyhow, I am sorry to burst your bubbles if I ever did, but I trust I did not, because I should not matter in that regard, is it? Yes, of course. Who am I to say anything about it? I am a nobody. Okay, girls who did not use TikTok are very few. I mean, you can ask in your community. We'll see. It's this thing is should I say it's very close to reality. You will hardly find less girls using this thing. There's more girls using that thing than they don't. And you will see also that men versus women who are using that application, women are on top of it because, women naturally are attention seekers anyway. And now we have these weak men who you will find that most of them are not seeing themselves as such anyway. But yeah, let's just leave the politics and before we start hurting people's feelings. Sometimes I am brutally honest, unfortunately, which is why many people around me don't like me. They think I am bad, I am brutal, I am cruel. But I'm like, it's better that they don't like me for the truth than to like me for just, going through the motions and embarrassing myself in the process. My reputation is clear, folks. You take it or you leave it. Wow, what did I just say? Nothing, folks. You didn't hear that. I was just having a moment, okay? Yeah, I was just choking, folks. Nikki, so the total of girls basically that we have is 130. So this is a two-way contingency table. It's very important, by the way. This is what we call a two-way contingency table. It's a very important tool also for probabilities to know how to use. Okay, now, hey guys, I'm losing time, man. Oh, the time I wanted to use. Come on, guys. What is this now? Anyway, let's move on. Now the boys that don't use TikTok is those ones. And now these are true men. Okay? TM boys. These ones are weak boys. This is WM. They must not exist. In fact, I want to kill these boys if I see them somewhere. Anyway, let's go to this one. Nitobatlaya. Aningababona nitobatlaya. So I better make sure I don't see them. Okay, that is the total of boys. And of course, the grand total is 250. Now, let's leave the ones in total who are using TikTok are these ones, and the ones who don't use TikTok are those ones. These are probably my friends. Okay, the rest, damn it man, I doesn't want to see you. If I can speak English incorrectly, deliberately. Okay, yeah, whatever. Now, folks, we've got a situation here. We've got 11.2.1. We are told a name is drawn randomly out of the group, meaning the 250 people. Now, what is the probability that the name drawn will be a girl and using TikTok, meaning these two happening simultaneously? Okay, all right, okay. So the number of girls that are using TikTok is 105. So you can say the probability of being a girl intersect TikTok, because you want these things to happen simultaneously. Let's not even do things that are crazy. Let's just say the probability of the event is going to be, the number of girls is going to be 105 over the total, which is 250. You can simplify this or you leave it like that. It's not a big deal. 105 divided by 250. This is 21 over 50. Again, you can leave this as a fraction, you leave it as a decimal or a percentage, it's up to you. Technically here, the answer is the mark. You can even mark it there. It's not a big deal. Now, events, are the events being a girl and using TikTok? Now, this is two in events. It's either you are using TikTok, we don't care who you are, and being a girl in general in this group. Is it something that is independent? Meaning, is there an intersection there? Let's find out. How do we test whether events are independent? We need to find that P of being a girl multiplied by P of using TikTok is basically equal to the probability of being a girl and using TikTok. Okay, I'll just put it that way. Now I guess what we wanted to write is probably correct. You know, being a girl and then you intersect TikTok. So we are trying to test the product rule in this regard. Now, let's see. This is how we answer this equation, 11.2.2. Let's first find out the probability of being a girl in here. How many girls do we have? We've got 130. Mamacitas against a 250 background of a total of students. Now that is the probability of being a girl in this group. We don't care about other things. Now let's see the probability of using TikTok. Now this is just general here. How many people are using TikTok is 173 over a total of 250 people. So that is what we've got. Now let's see. What is the probability of being a girl multiplied by the probability of using TikTok? This is going to be 130 over 250 multiplied by 173 over 250, which is this one. Let's see. Maybe here we can just simply say this is being a girl and essentially using TikTok at the same time. It's good like this, ne? And then let's see, this is going to be 130 divided by 250 times 173 divided by 250. Essentially, this gives us a very silly number. So let's just do it to two decimal places. This is 0.36 to two decimal places, because it's coming out in an ugly manner that I don't like. Now, can you see what is this one, by the way? If you were to show that one in decimals, 21 over 50 is basically 0.0 0.42. Can you see? This is not equal to the probability of being a girl and using TikTok. Okay, maybe let's just put it this way, which is not equal to 0.42. We can say since P of being a girl multiplied by P of using TikTok is not equal to the probability of being a girl and using TikTok at the same time. Therefore, the events are not independent. Ya senibhala kabi ngomxesha lami selimosheke kakhulu ke bantakwethu. Senthethe nezinto ezimbi ezifoul and nizongishaya. Akusenandaba, I am as guilty as judged. Okay guys, so we proved these two things are not independent because a 0, this one here, this one there is not equal to this one there, and this one we found out above, this one we found out now. So since that is not the case, the product rule doesn't hold, then the events are not independent. Ne? This is not, guys, not independent. Okay, so that is it, guys. 4 marks, easy. So what is important here, Bafueto, is this step here and this answer there, 2 marks. And then this conclusion is very important and essentially highlighting that those two are not equal. Highlighting that those two are not equal. Okay, so here you can even indicate that this is the probability of being a girl intersecting using TikTok. TikTok, I don't know, man. Sometimes some questions are a bit cumbersome. Okay, guys, let's not move slowly. So let's do 11.3. With 11.3.1. It says now a group consisting of 5 boys, 6 girls, and a teacher goes to the movies. Okay, right, this teacher is too social. These kids are not going to respect you, man. Don't do it. They buy 12 tickets in a row next to one another. Okay, one of the seats is next to the aisle. Okay, this is now the passage between the, you know, the groups of seats or the row of seats, whatever. So it says now, in how many different ways can they be seated? I mean, there's 11 students or pupils plus 1 teacher, so there are 12 in total. So if we put them randomly, we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now this means for this first seat, because we're putting them randomly, it can be any one of the 12. Once we place 1, it can be any one of the 11. Once we place the 2, it can be any one of the 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And we're just multiplying all of those possibilities. So you will feel like this is crazy, but it is true, Buffett. This is 12 factorial. Now let's put it down on the calculate. 12 factorial gives us a 479 million and 1,600. Yawena utengathi nento ezininzi nje wena. Yo, 479 million and 1,600. Yo and 70 ibe seyipheleleke kanjalo. Now this is it, guys. They were just giving you 1 mark, so nothing major there. 11.3.2. It says now, to avoid disruptive behavior, it was going to happen, right? The teacher considers to place the following restrictions. This question is always the troubling one. The teacher at the end next to the aisle, okay? Next to the passage, so that these boys don't jump around. They must pass through this one. before they can get out. And the children in any order, can you see, in any order, as long as Peter, the naughty boy, and John do not sit together, because those two are the legends in this class or in this group. Okay, so now calculating how many different ways can they be seated. Nah. Okay, so now this one is pretty silly. It's a silly question. But remember, at random, there are 12 factorial, right? Meaning they can sit in any order. You may find Peter next to John as many times as it is possible at random under normal circumstances, which is part of that 12 factorial. But then let's say if we're saying these guys now, out of the 12 factorial, we are saying we want them together because it's much easier to solve this puzzle when we put Peter and John together, right? It's easier because to separate them, it's going to be a bit of a situation. But if we place John and Peter next to each other, it's much easier because we can see that, let's say Peter and John are next to each other. Next to each other. This is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now the teacher is fixed. Let's say this is the aisle right here. So the teacher is here. There's only one option for that first seat because the teacher is next to the aisle. Okay. Now these guys, we are saying Peter and John must be next to each other. So this, let's say we are taking this position here. So there's two of them. It can be either John or Peter. And once you place one on the other seat, there's only one option left. So they essentially make up a 2 factorial. Now, let's see what is next. Remember, this one is fixed. We're not going to tamper with it. Now, the other kids are how many? They are now, we've taken 3 people out. So 12 minus 3 is 9. So this is going to be 9, 8, 7, 6, 5, 4, 3, 2, 1. But these dudes here, they can be placed in that position, or they can be placed in between those ones, in between those ones, in between those ones, in between those ones. So I'm targeting the in-betweeners. Okay? So meaning these guys can be put in this way if John and Peter are to be next to each other. It's going to be 1 multiplied by this 2 factorial. But now this 2 factorial can be in these positions 1, 2, 3, 4, 5, 6, 7, 8, 9, and actually 10. So this is times 10. And then multiplied by this 9 factorial now of these other kids. Okay, so this is this is how many ways these folks can be put. Okay, so the other way other people look at this, okay, this is going to be that situation. Let's just count it. 1 times 2 factorial times 10 times 9 factorial. So this gives us a 7,257,600. Okay, so this is 725,000. You're lying. How many numbers do we have here? 1, 2, 3, 4, 5, 6, 7. So this is 7,257,600. Okay, cool. Can you see? But the other way to do the same thing is to say, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You know that the teacher is fixed, so we're not going to tamper with the teacher. It's next to the aisle. Then we can say Peter and John are next to each other as a unit like this. And then we can simply say this whole shenanigan can either be here, or here, or there, or there, or there, or there, or there, or there, or there. So this is how many things is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, wait a minute. This is how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, 12. So it could be there. So it's not complete. Now we can see that, okay, all right, okay. These guys can be in this position or in the next or in the next or in the next or at the last position. So you can simply say this is 1 times 2 factorial for these guys, yeah, multiplied by, this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you can say 10 factorial if you just want to not worry about the others. This should give us the same thing. Okay, so you've got two options to say John and Peter must sit next to each other. So now if they are not to sit next to each other, therefore for John and Peter not to sit next to each other, it should be equal to the 12 factorial, which is the random sitting, minus the sitting of them next to each other, which is going to be 7,257,600. So that is going to be the story. Now let's see, this is going to be that 479,001600 minus 7,257,600. So this leaves us 47. What is this? 471,744. Yeah, that is the one. That is the one, guys. So it's basically 12 factorial minus. Now we're going to say here 2 factorial times 10 factorial. Yeah, it's 471,744,000 ways. Now that is the answer to the question, because we wanted to find out in how many ways must they not sit next to each other. So it has to be the random sitting, because here this includes even them sitting next to each other, even them not sitting next to each other. So if we take the total and we subtract them sitting next to each other, we actually get them not sitting next to each other. So this is just an indirect question. Again, this question is a higher grade question in this segment. Sorry, it makes you want to cry. Okay, Bafweto, it's done. So we've got 11. What are you doing? So we've got 11.3.3. Okay. It says now, Duncan wants to sit next to Susie. If the whole group of 12 are seated at random, what is the probability that the two of them will sit together? Okay, that's another higher grade question that is also demanding of a student a bit more attention. They will always get an application of probabilities. Now we've got again these guys 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now we are saying Susie. Now we're going to take these two that want to sit next to each other. There's two of them. It can either be Susie or Susie and Duncan. So there's two possibilities for that chair and one for the next. That's if we're making them sit randomly, because they can interchange. And then we can say these guys can be here, they can be there, 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 they can be there. Or you can use this technique of mine. It doesn't matter. So we can see here that these guys can sit in how many ways? This is 2 factorial multiplied by, this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that is going to be 11 factorial. So that is how many ways they can sit together, those guys in this group. So this makes us to get 7, 9, 8, 3, 3, 600. We can say, therefore, the probability of the event occurring is going to be this 798333600 divided by 12 factorial, because we're saying they must sit randomly. Okay, so at random, we just look at that. Okay, but now we want to also consider the possibility of these two sitting like the way they want to sit. So this is 798333600 divided by 12 factorial, which is the total. So it gives us a 1/6. Wow. Cool. Okay, guys, we are done here. And I hope you guys are not going to kill me for almost taking 4 hours doing a 3-hour paper. It was not intentional, but sometimes I love explaining things, and I love, taking you through step by step, so that when you are faced with these things, you just sort them up yourself, and it makes life ever more fun. So, okay, guys, please keep practicing. Review this paper with me by doing it. If you didn't write it, those who wrote it, just review it with me on this video and see what were the points where you probably didn't get the idea, or what were the areas where you may have made mistakes. Otherwise, if you pick up any mistakes in what I did, you let me know, so that we do not lie to one another and we think we've got it all correct, only to find that we messed up. So for this one, the 3 marks is basically trying to find the number of ways in which they can sit in this restriction, and then substituting into that formula of probabilities and getting the answer. So this is how this whole 150 marks could have gone for a student. I'm sorry that I took a bit longer, and I said some things, okay? All right, okay? So you can cry about it if you want to cry. You can laugh about it if you want to laugh. You can ignore it if it doesn't matter in your life or whatever. But for me, I'm just sometimes outspoken, and sometimes that rubs a lot of people wrong. But don't worry about what I am and how I am. Let's just focus on the maths. And guys, I'll be posting a few more other videos. I'll look for a nicer paper too that we should do together to try and show you how to work through a paper 2 exam. Okay? And we will do the same for physics and chemistry. I hope you are going to do well and get those distinctions at the end of the year. Goodbye.